I didn't find the feet. All of them were just out. So I apologize for that. Having said that, coming from the Human Sciences Research Council, also I think that the humanities aspect of it in real science have been perceived not to fit very well. Our message is that, as I'm coming here, to hire the thinking as to where the social and the humanities fit into our ideas and thinking as scientists. That is our expectation. Having said that, it is going to be our wish and desires to see that kind of integration in the discussions that we are going to have, because multidisciplinarity is a new norm in science and development. We wish you all the best, and thank you for finding time to come here. Thank you so much.
And our next speaker in the partners is Stanley Maposa from the Academy of South Africa. Asaf.
Program Director, thank you very much for an opportunity to speak. I'm the only person here whose surname can quickly convert to be close to the #1 person in the country. If you add Ra to my surname, Maposa, you will start to look at me differently. I am pleased to represent the Academy of Science of South Africa, which is a host to the International Science Council Regional Office for Africa, and which is a friend to the inter-academic partner and a member. And our past president is here, Professor Rabi. And within this province, our president is here, Jonathan Jansen. The Academy of Science is made up of top scientists in the country. And our role is to, among other things, provide science advice to government. And our interest here is to see other players that are in the space and collaborate and do this more so that science will make sense to society. Thank you very much.
Thanks very much for those warm words of welcome from all our supporters and partners. I'm now going to hand over to Carolina and to Marky to do the introduction for everybody else.
Good. I'm going to hold the microphone.
All right, welcome everyone. My name is Carolina Odman. I'm from the University of Western Cape in the Physics and Astronomy department, and I have this special chair because before you think I'm some crazy princess, I had surgery a week ago, and so I would either take part from home online in this chair or here in this chair. So bear with me, thank you. We have a few comments for you just about how we're going to connect and network and meet everybody. We actually are going to have to go around the room and ask everybody to say something in 10 seconds. But before we get to that, there are a couple of things. You will have seen your badge has a lot of empty space. The point of that is to write on it what you want, what you think is of interest. So maybe you want to put your social media handles, maybe you want to put your area of interest or something. The idea is to use this to communicate with other people so that people can see, what is of interest to you. Also, we would like to carry the conversation, carry on social media. As you know, this workshop was oversubscribed and it is packed. A lot of people have a lot of interest in this area. And so if we can have the conversation online as well as in this room, that would be fantastic. We have a hashtag. The hashtag is Science4Dev. So science is the full word, number 4, and then dev, because it's both short and explicit. And now when it comes to the 10 seconds presentation, we'll be honest.
A very warm welcome to you all, those who flew in, those who drove in, those who walked in. I know there's a lot of jet lag in this room. Very warm welcome to South Africa. My name is Maggie Jangis. I'm an associate professor in the Information Systems Department at the University of the Western Cape. We're here to foster collaborations, to foster a multidisciplinary approach to make sure that we walk away with something that we can continue post this workshop. So we are going to do a 10-second elevator pitch where you introduce yourself, research interest, allowing other people to know what it is that you're doing, and over the break they can come over to you to see how they can foster a potential collaboration moving beyond the workshop. So I think this is not a roving mic. So the practicality of this would mean someone actually raising their voice when you stand up to actually speak. So literally 10-second elevator pitch. Just introduce yourself, your research interest, with the main aim of someone listening and going, I would love to collaborate with someone like that. And we will start this side of the room.
I'm Pierre van Eyden. I'm an astronomer by training, but right now I'm only an administrator at the National Research Foundation, looking after the national facilities in the country.
And no need to clap, 10 seconds just going around. Thank you so much.
I'm José Miguel Rodríguez Mendoza from Spain, and I study the hardest galaxies in the universe. I'm also Assistant General Secretary of the
Morning, my name is Alberto Sandro from Universidad de Armandad in Mozambique, Energy Environment.
Hello, my name is Jamal from the most northern part of Africa and the largest country in Africa. If you don't know where, then you have a problem. I'm from the university, I'm a physicist at the University of Constantine, Nigeria, and I'm also the president of AFAS. Thank you.
So we should say we're streaming this, so there's also people watching online.
Yeah, good morning. My name is Dr. Evans Nikeri. I'm from Jaramogi Oginga Odinga University of Science and Technology, the university with the longest name in Kenya. Jaramogi Oginga Odinga University of Science and Technology. My interest is in food security and specifically the use of edible insects for attaining food security. For those who could be interested, I've got some samples of how we can use these insects as food. Thank you.
Morning, everyone. I'm J. Subhash Jayakumar. I'm a lecturer in medical education at the Faculty of Health Sciences, University of Cape Town, and my research interest is undergraduate medical education. And that is like one of the SDGs, it's a quality education. That resonates with me. That's my passion. Thank you.
Who's next?
Good morning. I'm Arek Mikhailian from Armenia. This is a country, one of the countries hosting regional office of astronomy for development. So we have this road, which is part of this OAD. And also I'm the director of Burakan Astrophysical Observatory.
I'm Gor Mikhailian. I'm also from Armenia. I'm an astronomer and my research field is infrared galaxies.
Samir Panji, I'm a bioinformatician with H3 Bionet, which is a Pan-African bioinformatics organization building bioinformatics capacity on the African continent. And my interests are in infrastructure, analysis, and education.
Stanley Maposa, I come from the Secretariat of the Academy of Science of South Africa. I'm a social scientist. My work is strategic partnerships at national and international level. Thank you.
Good morning. My name is Onuchai Ugu. I'm an engineer with the National Space Research and Development Agency in Nigeria, a member of Astronomers Without Borders, and the project lead for IDP Children's Astronomy Outreach Project. IDP stands for Internally Displaced Persons. Thank you.
Morning, Daniel Kahnemer from the observatory here, SAO, and I'm involved in science engagement and focusing mainly on the 200-year celebrations this year.
I'm Ajit Kembavi. I'm the Vice President of the International Astronomical Union and I'm closely associated with the OAD. These days, I apply big data and artificial intelligence to all problems of interest.
Morning, everyone. My name is Daniel Mukhafan, as I said, working for Department of Science and Technology as an administrator for multi-weight astronomy projects. I'm also a student from University of Witwatersrand, doing my PhD on mega astronomy infrastructure projects and looking at how they affect society. I think it's almost the same thing as astronomy and development. So I'm here to learn and here also collect a lot of data.
Okay, so you heard me already, Petri, but in addition to organizational things and development in general, I already found somebody to talk to. Infrared galaxies, yay. I'm an astronomer.
Morning, I'm Thelma Oppold from the Human Sciences Research Council. I'm a research psychologist by training, but I'm specializing as a bridge builder. And I'm always getting into trouble starting those debates around equity, diversity, and inclusion. And my projects are around finding the connections between big science and human development. And especially where the people on the other side of the conversation don't believe the scientists are listening, and forging those community engagement strategies to actually create the foster bottom-up approach.
Morning, everybody. My name is Cheryl Walker. I have a research chair at Stellenbosch University in the sociology of land, environment, and sustainable development. And amongst the projects we're looking at are astronomy, but also renewable energy in the Northern Cape and its local development and national impact.
Good morning. My name is George Miley, an astronomer at the University of Leiden, who is hosting the European Regional Office. I was an IU Vice President when the OAD was set up, and it's really very nice to be here.
Good morning, everybody. My name is Daniel Moketi from Center for Advanced Computing of the CSR. I'm an astrophysicist by profession, but I'm responsible for space and astrophysics project using supercomputer. And I'm also responsible for the training programs. We do a lot of training within the big data in South Africa and also in some of the SKA readiness countries.
Morning, I'm Sarah Nanjemanakut, originally from Madagascar. I'm passionate about science engagement, and I'm also the early career representative of the African Astronomical Society.
Good morning, everybody. I'm Antonia Narazonarvelu from the University of Antananarivo. I'm a master's student in educational science in physics and chemistry, and currently I'm working about astronomy teaching.
Good morning. My name is Claudio Moises Paulo from Mozambique. I'm an astronomer working in Galaxy Cluster. In Mozambique, my role is work to convince my government to consider science as a tool for science. Out of being an astronomer, I have a background in weather forecast, so I'm working to make a bridge between astronomy and climate change.
My name is Tiamo Mtsewa. I'm from the Department of Computer Science, University of Botswana. I do what most academics do in a big university in a small country, which is slaving away. I teach 200 students undergrad. I have 3 master students. I teach senior undergraduates. I do research projects. I've got PhD students. I engage in national policy discussions, and I want to do more collaborations regionally. We're very, very keen to develop relationships with partners like yourselves to make sure that everything that we do has got impact on society. I'm currently involved in a project to do university industry government co-creation, which is what I think is very, very pertinent going forward. So I'm very, very happy to be here.
Let's not forget to keep it at just 10 seconds. So let's stick to the topic areas. Topic areas, that's what we really want to foster, that collaboration on our topic areas for people to actually contact us. There'll be plenty of time to talk more tomorrow. So if you feel that your elevator pitch was not well placed, there'll still be more opportunity. But if you could just introduce your name, topic area, what you're interested in. Thank you.
Cool. Morning, I am a Jedi, and I'm interested in transforming Africa through education. If you want to know more, come and talk to me.
Hi, I'm Delia Marshall. I'm from the Department of Physics and Astronomy at the University of the Western Cape with an interest in undergrad physics education.
Hi, I'm Izumi Hansen. I'm from the IAU's Office for Astronomy Outreach, and my focus is in astronomy communication and outreach.
Hi everyone, good morning. My name is Leila Kanish and I work for the IAU Office for Outreach in Japan. And we are interested in establishing collaboration with you all on a field of outreach for development.
Good morning. I'm Sarah Blythe from the University of Cape Town. I'm an astronomer. I'm interested in galaxy evolution, particularly neutral gas in galaxies and using the MeerKAT to study that, and the SKA. And on the other side, in education, I'm the co-director of the National Astrophysics and Space Sciences Program node at UCT, which teaches postgraduate astrophysics and space science.
Hi, I'm Claire Davis Reddy. I'm from the South African Environmental Observation Network. I'm the lead data scientist there, and most of our work is focused around making data accessible in order for decision makers to manage risk.
This way? Yeah.
All right, I didn't have to stand up. I'm Renee Khan-Korteweg. I'm an astronomer at the University of Cape Town, working in extragalactic astronomy, large-scale structures using all kinds of wave bands. And I'm also the chair of the steering committee of the OAD.
Let me start up for the convenience of the audience. I'm Anelda van der Walt. I'm South African. I have a small company who help researchers lose their fear of technology across Africa.
I'm Patricia Whitelock. I'm from the South African Astronomical Observatory and the University of Cape Town. I've been involved in the OAD since the beginning, and I'm involved in international collaboration through the IAU, and I'm interested in almost everything.
I'm Brian Masara, Executive Officer of the South African Institute of Physics. Our interest as the Institute of Physics in this event is physics for socio-economic development, and currently the project that is related to this that we are doing is entrepreneurship for physicists and scientists. Then additionally, I'm also interested in this because I'm working on technology foresight, that is looking at research that is happening and then predicting those areas in which a country can focus its resources so as to increase its impact in terms of those projects that will be successful. Thank you.
Hello everyone, I'm Rosa Doran from Portugal. I am a physicist by training with expertise on black holes, but I have an interest in teacher training, so I have a PhD in science education, and my power is training teacher. And I'm here because of the PLOAD, the Portuguese Language Office of Astronomy for Development.
Hello everyone, I'm Gustavo Rojas. I'm Rosa's colleague at the Portuguese Language Office for Astronomy for Development. I'm an astrophysicist by training in star formation, but I've been working with science education and communication for the last 10 years, so that's my main interests.
Hi, I'm Neeraj Mohan Ramanujam. I've been working since last year across the road at the South African Radio Astronomy Observatory. I'm originally from India, and I'm a member of the Public Outreach Education Committee in India. And my interests are large-scale mass campaigns or astronomy view on low budgets and science literacy.
I'm Zachary Kam from Burkina Faso. I'm an astrophysicist at the University of Joseph Kizerbo. And I'm interested to education and astronomy.
Hi, I'm Anna Scaife. I'm an astronomer specializing in artificial intelligence. I lead a program called Development in Africa with Radio Astronomy, DARA, Big Data, and its sister program, Radio Astronomy for Development in the Americas, both funded by the UK Newton Fund. Please talk to me about human capital development.
Right, I'm David Ikema with apparently a taller head than fit on the camera. I'm from the University of Cape Town, from IDEA there, a computer scientist by background, usually computer science and something else. So it's been different things. My PhD dealt with data centers on unreliable power grids, so think ESCOM, and now I hang around a lot of astronomers.
Tanya Graham, Head of Policy at Manchester University. I connect research from across the whole of the university to policymakers to affect evidence-based policy making, and I'd love to talk to you further about it.
Good morning, everyone. My name is Leon Orota from Tanzania. I'm a remote sensing specialist focused on natural hazard mapping.
Hi, I'm Joshua Kalognia from Ghana. I work for the Council for Scientific and Industrial Research. That's the Institute for Scientific and Technological Information. I work with an outreach team in astronomy for developing Africa. Thank you.
Morning, everyone. My name is Charles Takalana. I am a junior astronomy policy researcher at the Department of Science and Innovation. I do everything astronomy, policy, research. So I'm just astronomy on life scale.
Morning, everyone. My name is Tawanda Chimboja. I'm a development economics fellow with the OED. My interests are GIS and also tracing the development, the science, the development impact of science projects.
My name is Kefli. I'm from Mekelle University, Ethiopia. I'm an geo-engineer working on geohazards, especially landslides, and large scale also water harvesting and sustainable infrastructure.
For a moment, we thought we'd forgotten about us.
No, we don't.
Good morning, everyone. My name is Nomasumi Kasa. I work for the International Science Council, the Regional Office for Africa, and my focus at the office is interdisciplinary collaborations in the continent. Thank you.
Good morning. My name is Kyla Forbes-Biggs, and I am a translator, per se. Not necessarily of languages, but I translate from science to policy to communities. So I hear voices. And if anybody wants to talk to me about finding ways to get their messages across, that's what I do. I deal with disasters and vulnerable communities.
Good morning, colleagues. My name is David. I work from the University of Venda. I am in physics department and also researching on application of renewable energy for rural development. Thank you.
Hi, Tim Spuck. I'm with AUI. I'm the Director for Education and Public Engagement. My interest is in the development of innovative STEM education and outreach programs that transcend boundaries to improve opportunities for all.
I am Daniela Lázaro from the National Observatory in Rio de Janeiro, Brazil, and presently I am member of the steering committee of the OIL.
Hi, I'm Tsilavo, PhD student from Madagascar, based at the University of Cape Town. So I am working on past history and human activities in Central Highlands, Madagascar. And how can I apply those past data for the development of my country and my continent and the world? That I'm gonna find out here. Thank you.
Good morning, everyone. My name is Pedro Russo. I work at Leiden University, where I teach science communication and science engagement, and also work closely with the Regional Office of Astronomy for Development of the IAU. And my interests are really the interface between science and society and how science can make our society and the world a better place.
Hello, I'm Munira Hussain. I'm a master's student here at SAO and at UCT, interested in galaxy evolution, and I'm helping out the OAD today, and I've worked with them as an intern a few times. So very interested in development and learning how we can use science to make a better society.
Good morning, everyone. My name is Felix. I'm a researcher and data scientist at the Center for Health and Development, University of Port Harcourt. I have over 10 years experience working with data. I'm a member and also one of the coordinators of the Early Career Research Group of the Committee on Data, on Science, Co-Data. My job is to help government and non-governmental organizations use data to improve policy and also decision making. Thank you.
Good morning. My name is Paras. I'm an electrical engineer from India. We electrify remote villages in Himalayas, and post-electrification, we convert them into new destinations for community-based tourism. Thank you.
Good morning. I'm nursing back through, so that's the loudest that I can go. My name is Sonalis Gotra, and I'm from
the Global Himalayan Expedition India. I am the program manager for an initiative called Astro Stays that we started last year in the Himalayas, top north of India, where we use astronomy as a developmental intervention tool to create sustainable local opportunities for the indigenous communities.
Okay, good morning, everybody. I am Sulisa from Thailand. I'm working as a Foreign Affairs Officer in National Astronomical Research Institute of Thailand. So if you would like to know more about astronomy in Thailand, international collaborations, and so on, please feel free to talk to me. Thank you.
Hi, it's me again, Thomas. I'm an industrial engineer in systems analysis. I'm crazy about the application of systems thinking and system science in a variety of disciplines. And I hope I can inject that spirit to all of us. Thank you.
Good morning, everyone. My name is Joyce Kuno. I come from SASTA, South African Agency for Science and Technology Advancement. I'm here to collect data in terms of why you do what you do, how you do it, and what change you intend to make ultimately and ensure sustainability.
Good morning. So sorry for my poor English. I am from Colombia. I studied economics and I have a master in public affairs. I have working in my country, specifically in my department, Valle del Cauca, improve and update the science, technology, and innovation planning. We base our research on the premise that science, technology, and innovation should not be only at the service of business or economic sector, should be at the service also to resolve our problem and environmental problems. Thank you.
Good morning. I'm Sigla from University d'Abomey Calabi, Benin Republic, Francophone Africa, West Africa, the country neighbor Nigeria West. I am teaching logic, epistemology, history of science and technology, and innovation studies.
Good morning, all. I'm Marius Fermondo Tincho. I'm from the University of Cape Town, the Division of Medical Biology. My personal interest was the diagnostic and treatment of HIV, but I'm more interested actually in tropical and neglected diseases, the immunology and the diagnostic.
Good morning, everyone. My name is Makana Pashu, and I'm from NRF SASTA. We are a science engagement organization. So I'm from the Science Education Division, and I'm mostly interested in career development for the basics, FET, and early childhood development, and also coaching and mentoring for the undergraduate and postgraduate. Thank you.
Yeah, morning, everybody. My name is Takwani Samachemeze. I work for Dataface from the University of Cape Town. I've been working with remote sensing data to assess development at the local level. So I hope to learn more about what data is collected by astronomers and how we may use it.
Hello, everyone. I'm Sunita Patna. I'm from the University of Mauritius. My field of expertise is sustainable agriculture and food security. And for the past 15 years or so, I've been working on climate change, how it affects agriculture, how it affects our food, and what we can do about it to make our farmers and ourselves more climate resilient.
Good morning, everybody. My name is Regina Poloncho from the Nigerian Institute for Oceanography and Marine Research, and in the Department of Marine Meteorology and Climate. So I'm here to learn more about astrology for development for the coastal environment. Thank you.
Good morning, everyone. I'm Julian Geprak, Associate Professor from University of Yaoundé, Cameroon. We are working on green agriculture using pesticides and fertilizers of plant origin for more and better food and feed for clean and healthy environment. Thank you.
Good morning, everyone. I'm a software developer at Seon. I work mostly at building open source user interfaces for data management.
Good morning, everyone. I'm Jeremiah. I'm an academic librarian at the University of Cape Town. My interest lies in open access and open science and how we can use open access and open science for development.
My name is Timothy Tamai from Lesotho, chemical engineer by training. I work for an office called NOL, National Institute of Lesotho Research and Innovations. So what we are doing is we test ideas in the lab, incubate them as businesses, and then we push them for mass production.
All right. Good morning, everyone. My name is Olumuyiwa Adebayo. I have a background in computer science, and I'm interested in how we can maximize artificial learning and artificial intelligence and machine learning to prevent suicide. I work as a project supervisor for the Africa Project Against Suicide. It is in about 16 African countries. Thank you.
Hello everyone, I'm Margarita. I'm a postdoc at the University of the Western Cape, and I'm the coordinator of the Astronaut Fiber project, which is sponsored by the OD, which brings weekly astronomy activities to 5 schools in Kaliche and Philippines.
Hello everyone, I'm Lucia Marchetti. I'm a postdoc at University of Cape Town and University of Western Cape. My daily life is multi-wavelength astronomy and galaxy evolution, but also big data visualization, exploiting virtual reality and planetarium as well. In my other life, I'm also a science communicator. I do a lot of different projects, and today I'm here representing Subbox Science in Cape Town and how we can contribute to development through that network.
Good morning, everyone. I'm Cindy Jansen. I'm from Cape Town, and I work both independently and collaboratively in my field, and my field focuses on the development and growth of organizations and people and projects. Thank you.
Good morning, I'm Pondo Masuri from the University of Mpumalanga. My research area is on food security.
Good morning, everyone. My name is Rampal Gill. I work at the Rubin Observatory based in Tucson, Arizona, and my main focus is communicating to stakeholders.
My name is Richard Glover. I trained as a food microbiologist. I'm interested in traditional African fermented food processing technologies. I currently work as a program specialist with the International Science Council, Regional.
Good morning, everyone. My name is Philip Osada. I'm trained as a zoologist, ecological economist, and geographer. I currently work at the Stockholm Environment Institute. Our mission is to bring science and policy. My interest here is particularly in developing a program on science and environment diplomacy, working with missions in Nairobi to sort of strengthen the article science in the conversations. Thank you.
Good morning, everyone. My name is Michelle Willebrands. I work at Leiden University in the Netherlands, and I coordinate the European Regional Office of Astronomy for Development. And besides development, I'm interested in public engagement with astronomy, education, communication.
Good morning, everyone. I'm Lucas Maribate. I'm a data scientist. I am the chair of data science at the University of Pretoria, a principal scientist also at the CSR in Pretoria part-time. And I'm also founder of the Deep Learning Indaba, which is the largest grassroots-driven machine learning kind of summer school workshops in the world, not actually on the African continent, and that's actually started here on the African continent. So my areas are data science for society and a lot of work also in natural language processing. And I'm very interested, yeah, to meet you.
Hello, everyone. I'm Alami Imam from Ethiopia. I work from Ethiopian Space and Technology Institute. I'm also regional coordinator for East African Regional Office of Science for Development. I would like to work on astronomy for development, for better life. So if anyone wants to work on this area, contact me.
Oh, you heard me. I'm Clifford Momani, and I'm a paper pusher at the NRF. I'm responsible for research infrastructure. Next.
Good morning. My name is Darlington Onojafe. I work as a senior lecturer at the Cape Peninsula University of Technology, Cape Town. My interest is the management of relationships, especially when it comes to technical aspects of science and development for the benefit of community. Community do not understand the very strong language of technology development. So the technicians who are the developers, they also do not understand the benefit or the advantage of science for development in communities. So I'm here to just ensure that those communication and the relationship that is needed to succeed in science for development is achieved.
Good morning. My name is Niyi Abiola Kushimo. I'm an IT expert. I work with Work Fountain. Work Fountain is a multinational. We implemented trade for Nigeria and many other African countries and around the world. As a developer, it's my first time wearing a jacket in many years. As you can see, the button is not. So I'm here to learn from you all and to share my little knowledge on IT, how IT is like this button in research. Without IT, research won't fit.
Good morning. My name is Prosper Simpemba from Zambia. I'm a physics lecturer at the Copperbelt University. The Copperbelt University also hosts the Southern African Regional Office of Astronomy for Development. So my interest is to see that we use astronomy for development in the region. And we have a lot of projects on the wish list. So in short, I'm saying I have a lot of opportunities for funders.
Good morning. My name is Inameka Oluwama. I work with the Nigerian Space Agency, the National Space Research and Development Agency, which hosts the West African Regional Office for Astronomy for Development. So I'm involved in astronomy, outreach, and education. Research-wise, I do quality modeling.
Good morning. My name is Mitula Silengo from Zambia, from the Disaster Management Training Center at Bush University. My area of interest are disaster risk reduction, climate change, and building resilience for communities.
Good morning, everybody. My name is Elina Rietshoek. I'm the president of the International Astronomical Union. So I'm very pleased to welcome so many of you here. I'm also a professor at Leiden University in the Netherlands. My field of research is the formation of new stars and planets, and especially the chemistry that is involved in that. I'm a chemist by training, only gradually came into astronomy, so I'm multidisciplinary by training. I look especially at how water is formed in the universe and actually where the water on Earth comes from.
Hi everyone, I'm Grace McBride. I'm at the Office of Astronomy for Development. My interests are X-ray binaries and other neutron stars, but also in how we translate these methods from our astrophysics into other kinds of problems.
Good morning, everybody. My name is Daniel Nyanganila. I am an atmospheric physicist, but now I've been working with the National Science Council for the last 12 years. I'm the regional director of the National Science Council, Regional SWAT.
Good morning, everyone. My name is Deb Kelvin. I'm from the United States. A major part of our work is done or is focused on bringing astronomy and science education to the underrepresented and underserved.
Hi, I'm Kate Meredith. I'm a former classroom teacher. I'm with Deb from a small nonprofit in the United States. We are a member of the new North American Regional Office of Astronomy for Development, and we are absolutely passionate about making sure that all students with disabilities can participate in not only the products of astronomy, but the process of astronomy. And we're really engaged with authentic research projects for students in environmental action.
Good morning, everybody. I am Aouli Khassawi from Jordan, the country which hosting the Arab Regional Office of Astronomy for Development. In the meantime, I am also the Director General of Regional Center for Space Science Technology Education, affiliated for Western Asia, affiliated to the United Nations. I am here also just to establish a good cooperation with South African astronomers and others who is present in this event. Thank you very much.
Good morning, everyone. My name is Daya Reddy. I'm the President of the International Science Council. My day job, I hold the Research Chair in Computational Mechanics in the Mathematics Department at the University of Cape Town.
Thank you very much to every one of you who stood up and told us your stories. Apologies that we went a bit over time. But just to close this off, I'd like us to give ourselves a round of applause for the diversity that's in this room. And actually encourage you to reach out to people. Anyone who you want to collaborate with, go ahead and meet them. And this is a time to foster our collaboration. Thank you.
Thank you for letting us know who is with us. So now that we know, we are going back to Prof. Diane, who just introduced himself, to give us a key note speaker. He's the president of the National Science Council.
It took too long. Okay, it's just starting up. Yeah, there we go.
Can is it too short or just? Right. Good morning again, everybody. It's really wonderful to be here. And this really is a truly amazing diversity of participants. I'm really pleased to be among you. So I want to speak in my keynote talk very much to the theme of the meeting, which is on science for development and that of building bridges across disciplines. Let me start with one slide on the Sustainable Development Goals. Is this not on? Better. So, thank you. Let me start with this one slide on the Sustainable Development Goals, which in a sense is a consensus, a global consensus on the challenges pertaining to development and also indications of potential pathways to sustainable development. I want to focus though on, just a minute. It's on now. Right. I want to focus pretty much on, yeah, let me just, sorry. Yeah, no, I wanted to point, but it's okay, I'll cope. On health and inequality, and just draw out some very specific details of what exactly we are confronted with, and therefore what the challenges are broadly speaking, and what the challenges are for science and scientists in particular. So let me start then with health, and very particularly with health in sub-Saharan Africa. So of course, we had seen some developments through the period of the Millennium Development Goals. Nevertheless, we still have, despite progress in various areas in Africa, greater political stability, really an order of magnitude or more increase in foreign direct investment and the like. Still, the health challenges are significant. HIV has 25 million people infected in Africa out of 35, 38 million globally, which gives one an indication of the extent of the disease, of the virus on this continent. Tuberculosis, actually, the details I have about TB are global rather than for sub-Saharan Africa only. That map, that distorted map of the world, gives an indication of incidence of TB, or rather scaled incidence of TB rather than geographically. 10 million cases, 1.7 million deaths. On the other hand, given the advances and the more widespread incidence of treatment, globally speaking, really tens of millions of lives have been saved in this way. Chronic diseases, well, tuberculosis is an infectious disease, and so is HIV. And the picture one has, you know, of Africa very often when you talk about health and disease is precisely that of infectious diseases. Nevertheless, have a look at this graph over here, which we see a dramatic increase in non-communicable diseases, chronic diseases, heart disease, various cancers, obesity, and the like. That is a massive wake-up call for the continent. When we turn to inequality, again, I think most of you here are aware of the huge inequality and inequalities that we are confronted with in the world, and in fact increases in inequality as we have seen economic growth and so on, greater globalization. At the same time, we have had dramatic increases in inequality, and the champagne glass picture on the right-hand side gives an indication. It's divided into quintiles, and the key figure there is that something like more than 80% of world income resides with just 20% of people in the world. And there are other kinds of extreme figures in this way that I'm sure you've seen. Oops. Here is a chart that shows a relationship between life expectancy on the vertical axis and income per person. So if you have a very rough look at it, it follows almost a linear curve. There is almost a linear correlation between life expectancy and income. There are various outliers. The sizes of these discs indicate the populations of the countries concerned. And once again, if one looks at the bottom end of this figure, the countries that are indicated in blue there, largely in Africa. So very, very direct correlation between income, quality of life, life expectancy, and the like. So these are the kinds of challenges that we are confronted with when we talk about development. The United Nations Development Programme, UNDP, is an agency within the UN, which publishes an annual report. The 2019 report was published not very long ago. It's a very interesting document, a very long document, almost 400 pages long. It sheds light on what exactly has been happening with regard to development, but also more importantly for us, I think, what are the issues that we should be grappling with when we say that we are working towards improvements in development and that. What do we mean? How do we define development? The key, well, the subtitle of the report says beyond income, beyond averages, and beyond today. So beyond income, in other words, let's get away from single figures such as gross development product, GDP, as an indicator of development, which completely ignores other factors such as health, general well-being, dignity, human rights, and the like. Beyond averages, in other words, let's be careful about how we use data. There's loads and loads of data, but there is much that is masked simply by using and analyzing data in the wrong way, that is by simply working with averages, for example. And beyond today indicates that really we, of course, it is important, it's good to consider what is happening in the past, what is happening today, but really let us look beyond today. For example, to the kinds of challenges that the world is starting to face with regard to climate change, with regard to advances in technology, such as artificial intelligence and the like, with their huge impact on the lives and the lifestyles and working lives of people around the world. They have 5 key messages. I won't go through the 5 key messages in details. You can read them, but they, for example, the first one that pertains to the fact that the disparities remain widespread. I've mentioned 1 or 2 of the others which are contained in, if you like, the subtitle of the report, pertaining to exactly how we measure development and the like, and how we should be looking ahead. So, so I want to come to the International Science Council and development, and a little closer to our theme of science for development. So the ISC was founded in July of 2018 from a merger between what was ICSU, the International Council for Science, an organization comprising almost exclusively natural science organizations, together with over 100 national members, and the International Social Science Council. The main, I should say, the main thrust and rationale behind the establishment of the ISC was precisely to create an organization which would straddle the sciences, broadly speaking. In other words, across the natural sciences, technology, health sciences, and the social sciences and humanities. So the strategic objectives are, well, in a nutshell, 4-fold: promoting research and scholarship. We're not a research organization, but we take steps to promote research and scholarship through using our convening power. For example, we do an enormous amount of work at the science policy interface. We do a lot of work also in the domain of what is referred to as policy for science. In other words, policies, initiatives, and the like that will ensure that scientists are able to carry out our work right across the spectrum, from fundamental through to applied work, be properly funded for it, ensure that guidelines, rules, and the like are in place to support us in our work, and then also promoting scientific freedom and advocating for responsibility in science. So this map here shows you, gives you a sense of the extent of our national membership. We have members from around 140 countries, so that's around 70% of the countries in the world. There are gaps there, particularly in Africa, that we are working on. We need to close those gaps. We need really to get everybody on board. And then we also have, as you saw 2 slides ago, we have around 40 scientific unions and associations. And I think I've been able to put on the slide the logos of all of our scientific unions. The IAU is somewhere there. Mathematics, physics, and so on, but also sociology, political science, psychology, and the like. But if you glance across the slide, it'll give you a sense of the disciplinary diversity of the membership of the ISC. Extremely important also from the point of view of the multidisciplinary and transdisciplinary approach to the work that we take. You will have seen earlier that the vision of the ISC is that of science as a global public good. What do we mean by global public good? It's a good that's non-excludable, it's non-rivalrous. There are a number of examples there that I show on the slide. And we believe that science should be amongst that list of activities and objectives and the like that are public goods. So that's the basis from which we pursue our work. And what I'd like to do is give you just a few examples that, in a sense, illustrate the nature of the work of the IISc and also that indicate its interdisciplinarity and also the interactive nature of the work. So what you see there is a picture of a report that we published in 2017 on SDG interactions. So the background to this is that you've got the 20 Sustainable Development Goals, poverty, inequality, health, and so on. And of course, they do not stand as independent goals. There are significant interactions between them. In working towards addressing one of the particular goals, inevitably there are impacts on other goals, which may be positive or negative, and one needs to know what this is. So this was the purpose of this study. It was not comprehensive. It focused on 5 of the goals and the targets within them, and carried out an analysis which indicated where there were trade-offs, where goals supported, or targets for that matter, supported each other. That work is continuing now as the SDG Interaction is a national policy driver project. It's work that we are carrying out, as is very often the case, with a number of partners, and you see the partners' logos there, the Stockholm Environment Institute, the United Nations Development Programme, the Joint Research Centre of the European Commission, and also IIASA, the National Institute for Applied Systems Analysis in Austria. So the point of departure, in a sense, is that we want policymakers in particular to move away from the SDGs as being merely or simply a reporting mechanism, and really something that should drive policy towards aimed at sustainable development. And so this is the kind of work that will go on, various mapping exercises that will take place, very careful analyses, and then very close interaction with policymakers at national and regional levels. Really, so the idea would be that that we, together with our members, of course, would ensure that policymakers have a much better understanding. There's much greater input of a scientific nature into policies pertaining to the Sustainable Development Goals in various countries. This is another example of a truly interdisciplinary program, the Integrated Research on Disaster Risk Program, which we 5 minutes, thanks. With which we are partners with UNISDR, the United Nations Office for Disaster Risk. It's a program that is based, well, the office, I should say, is in Beijing, but it's a global program, and the objectives of the work shaped to a very large extent by the Sendai framework on disaster risk reduction. Yet another program, which in LIRA, which is Leading Integrated Research in Africa. It involves early career researchers in partnerships across universities, in fact, across countries. It is transdisciplinary in nature. That is the point of the whole program, developing transdisciplinary research expertise among early career researchers, because most of us really have, certainly people my age, have grown up in a very much a disciplinary way of working, funded by the by SIDA, the Swedish International Development Agency. Well, I'm coming almost to the end. I just want to make 1 or 2 remarks about the action plan of the IISc, which frames our work for the period through to late 2021. There are 4 domains. I'm not going to talk about all of them, but I do want to home in just briefly on the first one, which has got to do with the 2030 agenda, that is the Sustainable Development Goals. And here in particular, I'd just like to make mention of a program, a project, which we are carrying out in partnership with UNDP. So this goes back to the UNDP report, which I showed you, which I spoke about a short while ago for 2019. We are working with UNDP on the 2020 report, really to review, re-articulate the meaning, the dimensions of human development, pretty much addressing the kinds of questions that are posed in those key messages in the UNDP report. So working together with UNDP, providing very much the scientific, the computational, the numerical, the data expertise, although there is much of that in UNDP already. And eventually for this to see the light of day in the 2020 Human Development Report. So I think I will conclude at this point here. You see our web address there. Please follow us on Twitter. The vast majority of our activities are carried out in partnership, not so much at the IC offices in Paris, but really in collaboration with our members and with our many, many partners around the world. Thank you very much.
Thank you, Prof. Reddy. We'll save questions for the discussion session at the end. So can I invite Professor Van Dishoek to come and tell us about the IAU?
All right, good morning, everybody again. I'm standing here to tell you a little bit more about the International Astronomical Union and how it fits into Science for Development and Astronomy for Development. Now, as was mentioned already, we are celebrating our 100-year anniversary this year, or it was just last year. We're sort of in the tail end of it. And that was actually under the motto, Under One Sky, indicating already that we're all here as world citizens from many different countries under the same beautiful sky. We actually had a flagship celebration for our union in Brussels in April last year. And we didn't focus so much on astronomy. We really focused in that meeting astronomy with and for society. And so if you want to hear more about that, there's some wonderful talks actually on the website here from our 100-year celebration that you can watch the videos of those presentations. And I'll be using some of the material actually here in my talk. So since I think I counted about half of the participants have some astronomy background here, but the other half don't. So I'll say a few words about astronomy itself and the kind of research that we're doing, and in particular sort of how our view of the universe has changed over those 100 years, because I think it demonstrates sort of the enormous progress that you can make in science over a century. So if you look at 1990, what did we know then? We thought our universe was actually very small. We knew only one galaxy, our own Milky Way. Now we know, of course, that the universe is teeming with galaxies. There are hundreds of billions of galaxies, and several of the people here in the audience are studying them. We know that our universe is huge. We can look back to almost 13.8 billion years when the universe was formed in the Big Bang. We also know that the material that we are made of, the atoms and molecules, comprises only 4% of the universe. The bulk of it is in this mysterious dark matter and dark energy that we have no clue yet as to what it contains. 1990 was an important year because that was actually the famous solar eclipse that was viewed by Arthur Eddington from Principe Islands and also from Sobral in Brazil, And both of these expeditions actually confirmed that Einstein was right. And that was, of course, very important because that actually proved that you can use general relativity, and that plays a role in our daily lives in the positioning. Then last year we had sort of other evidence for black holes, where generally general relativity plays a large role. The galactic center of our own galaxy contains a massive black hole, and then this is the first image of a supermassive black holes in another galaxy, and this picture became famous overnight. In 1990, we didn't know where the elements in our own body came from. You know, we knew there were elements, but we had no clue as to how they were made. Now, of course, we know that they were made in the interiors of stars through nuclear fusion, some of them made already in the Big Bang, and in supernova explosions. And in fact, last year was also the International Year of the Periodic Table of the Chemical Elements. And also the chemists started to realize, okay, that's where our elements actually come from. In 1919, we were speculating certainly about planets around other stars. We've done that for centuries. But the first discovery, the first scientific proof that there were planets around other stars than our own sun didn't come until 1995. And now again, we know that our universe is teeming with planets. On average, every star has at least one planet. But there are other types that we don't have in our own solar system. So this whole diversity of planets that we have in the universe is something that is a new field that is growing there. And then, of course, we also want to know the composition of those planets and whether they could sustain life. And of course, the water molecule plays an important role in that. And finally, you know, how were we formed some 4.5 billion years ago? We're getting clues of that still from new missions that we have, to asteroids in the inner part of our solar system, and also missions to comets that are in the cold outer part of our solar system, and which are probably the most primitive leftovers of the formation of our own solar system. So again, it tells us something about our origin. So, science is important as an inspiration for the general public, for many different people. This is actually a slide from Dame Anne Glover, who used to be the science advisor to the commissioner of the European Union, and this is what she wrote: "Science can liberate." It is really important. And also, as was stressed several times in Brussels by non-astronomers, really that astronomy is a uniquely inspirational science in order to bring this excitement of science, to get young children inspired into science, not necessarily astronomy, but using astronomy as a gateway into science. And this is another wonderful quote that was put forward by Maria Popova, a science writer, a quote actually from a famous female astronomer: "To mingle the starlight with your lives, and you won't be flooded by travels." Going back to science, some general considerations. And one thing that you often hear is that there is curiosity-driven science and then there is applied science. To me, that doesn't make sense, because every science, what you do, has some application in society. It can be on long term, it can be on short term, but there is always some application in it. So to me, this sort of dichotomy between curiosity-driven science and applied science doesn't make so much sense. It's really short term versus long term. And of course, if there's anything that has really contributed to development also here in Africa, it's the mobile phone. It makes huge opportunities for people in Africa to do mobile banking, to do all of their business that was not possible before. And it's really based on science, on physics, you know, the Maxwell equations, mathematics that is embodied in there, chemistry that is embodied in there in the materials, and of course astronomy that is there in terms of the Wi-Fi that originated from astronomy technology. So that is just one example that, yes, this comes together all the time. Here's another slide that we had in Brussels. Here you see the world beautifully. It's the sun and the sky and the trees and the rabbits, etc. But now you see actually all the equations that are at the bottom of that are the basis of what you see there in that picture. So again, science is at the basis of everything that we see here in this world. Fundamental science is also important. Science for development is definitely then how you apply it to development applications in the short term. And we've seen already some very nice examples from Professor Rani here. One thing that we will definitely be discussing here is the issue of science for development versus development of science. And since astronomy is sort of the central hub in this discussion, we will be talking about development of astronomy versus astronomy for development. And I think an important statement that was also made repeatedly in Brussels is you cannot have the latter, astronomy for development, if there are no professional astronomers in your country. So using astronomy development also necessarily entails, at least in those still developing countries, that you also need to have some development of astronomy. So those two could actually go hand in hand. We've seen that astronomy is multidisciplinary. I'm really delighted to see so many of you that are actually in these other boxes here, technology and skills, culture and society, that you're actually here represented. And this has always been at the center here of the OED. You see this beautiful figure here represented there. There's also the growing importance of the space sector, something that we shouldn't forget. Certainly in my travels through the Middle East and also here in Africa, this point has come up again and again, that the space sector is growing. It's attracting a lot of bright young people, and this is, of course, space science is closely connected with astronomy. On the other hand, you can use those satellites to both look up towards the sky, but you also can look down on the Earth and then use it to study climate change and all kinds of other effects. And so this whole issue of space for humanity is also something that we should keep in mind. Okay, so a few more words actually on what the International Astronomical Union is. So we're the union of all professional astronomers, and our mission is to promote and safeguard astronomy in all its aspects, of course, through international collaboration. That is the key point. And these days, that's much more than just research. It's also communication, education, and development. We were founded 100 years ago, and we have some 13,500 members from 82 member countries and 107 nationalities. So we bring people together from across the world, and we share our knowledge through high-quality symposia. And we are delighted actually to have not the next General Assembly, but the one that is going to be in 2024, that is actually going to be here in South Africa. So the first time, finally, after more than a century, we're coming to Africa, and we're going to have our General Assembly here in 2024. So I think that's also a challenge for Africa to be ready for it and to make sure that Africa and African scientists are actually very well represented, not just as attendees to these meetings, but also as speakers at this meeting. So I think this is a very good goal for Africa to have. We have a new strategic plan that I would urge you to take a look at. Here is a hard copy, and we'll put it also in the meeting room. Because apart from stimulating research, we also do the communication and education, training and development, and we do that through 4 different offices. Our Office for Astronomy Education, that is just new, established in Heidelberg. Communication outreach in Japan. You heard Dina and Izumi there. Training, advancements of young astronomer, that's hosted by the Norwegian Academy of Sciences, and then here the Office of Astronomy for Development that we have here in South Africa, kindly hosted here by the SAO. We stimulate all kinds of inclusiveness and in various ways that you see here. Also women, especially young women in astronomy through various actions. For example, we have had last year a whole week sort of centered around women and girls in science, and just by communicating with each other, we were able to launch more than 300 activities in 67 countries and reaching more than 20,000 women and girls in that way. We do the education and training and development through various schools. This is the School for Young Astronomers, so this is really the training of astronomers. This is more an example of using astronomy to train young people in other aspects. So hands-on training in engineering at telescopes, and of course big data. And we have big data, and we use that also to train. And we can also use indeed what is happening with the sort of the weather on other planets to talk about climate change. We've seen what has happened on Venus. There's a runaway greenhouse effect, and so that is a very visible example of what climate change can do to a person. The OED, we are very proud of it, and big congratulations to Kevin and to Vanessa for making the OED into what it is today. It has grown from the office here in South Africa to the now 11 regional offices that are present. Just yesterday, we signed the agreement of the US road. We're very pleased to have them as part of our family, and so you see that we're well represented worldwide. And so all of these regional offices are doing activities that are related also to the SDGs. Here you see some examples. I was very happy that Professor Reddy also stressed the point that it should not be just reporting, it should be doing things and implementing things. And here are some of the examples that we have, of course, in education, the capacity building workshops that we have, a lot of focus on gender equality, that we're having here, community programs, that we have astronomy for diplomacy. I'll come back to that in just a minute in terms of peace, and activities targeting disadvantaged and underrepresented groups, and of course also oops, I can go back here. The light pollution is something that is very much on our minds. We have two new flagship projects, one of them on local socio-economic development, sustainable of that, and then also the science diplomacy through astronomy. That is one of our examples. And as you heard already, there's a very nice example in the Himalayas going on. Astronomy for livelihood creation is just one example where the challenge is to stimulate the economy in very remote areas, very little villages there in the Himalayas. The asset that you have is actually the clear night skies. That is something that's, that we can offer. And then the opportunity is then the community skill and engagement. And this is just one example how something that starts little and then can grow quite considerably by using astronomy in this way. And the other flagship is more centered around science and diplomacy. And it's actually interesting to think about what science diplomacy is, because it comes in many different ways. There is science in diplomacy, basically science advising that we give to our governments and to perhaps meet global technical challenges. There is diplomacy for science, so diplomacy basically facilitating international scientific collaboration. We also have wonderful examples of that, of course. And here is our big, large facilities. And then there is science for diplomacy, scientific cooperation, improving international relations. That's already science for peace. And so I think what you have here is the SKA and also Mr. Meerkat are already wonderful examples of these cases. It's also clear that this will only work politically if the science that you're providing is first class. And so I'm very pleased to see some of the first results coming out, for example, from the Meerkat array, that are really first class. You can do it also on a smaller scale with the younger generation. Here's a wonderful flagship project that we had for Astronomy for Peace piece here actually in Cyprus, where the two halves of the island, which are very much divided, were actually brought together with children at a young age and then doing activities in astronomy. Where are we going in the next 100 years? Well, nobody can look ahead for 100 years, but at least we can maybe look ahead for 30 years. Certainly one thing that we'll continue to stress is that the common goals that unify scientists, and that is joint facilities and big surveys. This is, I think, unique in astronomy, or at least astronomy is one of the big sciences where really those large facilities bring us all together and are a wonderful tool for doing all of this. Big data, of course, as well. New technologies, science literacy, these are all aspects that will grow in the coming years. Of course, the computational power will continue to grow. It was not so long ago that the terabyte seems a lot of data. Now it's very little. You have a terabyte per second coming from some of these facilities. So we're growing very large in the automated regime. At the same time, we should be a little bit careful because this is also energy consumption, a lot of it. So if we're thinking about our carbon footprint, this is something that we should keep in mind as well in terms of computing facilities. Our collaborations will continue to enrich society, both through the OAD, and as we've seen already, they are related to the Sustainable Development Goals. What is really the future is, of course, the next generation of children, and that is where we are also focusing on quite substantially. And again, this is where astronomy brings something unique to the table. It brings to the table unique inspiration and curiosity. It's an easy way to get young children excited about science. And once you have curiosity, that is a driver for innovation. So this is indeed something that we need to foster and that we need to develop. If you ask children what they find some of the most interesting questions, are we alone is definitely at the top of them. So I'll leave you with these three pictures that have huge impact on society. They each reach, billions of people. Just this picture last year was probably seen by 4.5 billion people. This, of course, the Earthrise is a famous picture that I think everybody has seen. And this one, the pale blue dot, when the Voyager missions were beyond Saturn and they looked back one more time towards Earth. And then they saw how tiny little our Earth is. This tiny little dot, that's us, that's our home. Carl Sagan gave it such a beautiful world. So this is what we should foster, and that is what we should continue to stress. Science and astronomy, they provide also inspiration, perspective, modesty, and tolerance in its words. Thank you very much.
So next up on the program, we'll have Tawanda Chibuse, who will give us a bit of a view on, from the development economic side, on what we should know scientists.
Okay, thank you very much, Vanessa and Daniel. So I think I should say right from the onset that I really like, the title of my my talk, but I also don't want to make the impression that I've got everything figured between as far as the link between science and development, because it's not really very much straightforward. So I'm a development economist, and I've just collected a bunch of talking points, which I think might be important, to help all of us, establish this link between science and development, in particular the link between astronomy and development. So there are three things really, which in my opinion, that science professionals might have to know. So the first thing is the development context. We have to understand why things unravel the way they do. So as science professionals, we might have these coding skills, we might have the technological knowledge to to kind of, to make stuff happen. But I think by and large, we also kind of, need to know what is the development context. What are some of the contradictions? What are some of the things that we are looking at? I think that's very important. Part of that is also to inspire you as a science professionals that you do have a huge role to play, in achieving development outcomes in developing countries and elsewhere in the world. And I think very important, we also need to know that development, yes, it can be about these big mega projects, but it can also be about the very small things, as I explained in my talk. So right, so at the Office of Astronomy for Development, we have developed a course called the Introduction to Development Economics for Non-Social Scientists. So this is the kind of platform or the channel in which we are trying to sort of, try and contribute in this Science for Development discourse. So I just want to talk about a few things with regard to development economics or with regards to development in general. So the discipline of development economics generally takes place in development in developing countries. That's more or less the setting of development economics. But it doesn't mean that there are also no development challenges in the developed world. Many countries in Europe and the US are struggling with issues like migration. There are plenty of challenges. So there exist development challenges even in the developed world as well. So the field of development economics is a very empirical discipline. What that means is that we need a lot of data. Yet we are also operating in a very data scarce environment. So the manager in 2013 said that with reference to Africa, there is an African statistical tragedy wherein governments, they don't have the money or sometimes the political will to make available objective and reliable data sets for use by researchers. Because for us to understand development challenges, we need data. But what this also implies is that science projects, OIT projects must be data driven. We have to know what has been the impact, the past 5 years, the past 10 years, what has been happening. We have to have a way, you have to have some bit of infrastructure, some kind of way that we can collect data, some kind of way that we can trace. We have to know whether those 100 perhaps students that we influence to take up STEM careers, where are they now? Are they in STEM careers? Can we see that kind of wage differential that will then influence the long run economic growth? Because in the US, there's some evidence that STEM careers they earn something like 10% more than non-STEM graduates. So that's a big that's a huge impact on the economy. So data skills and their transference is also key, because science professionals usually have got coding, programming skills, which they can also transfer to other disciplines. In my own PhD, for example, it was an economics PhD looking at land rights, the effects of land reforms and things like that. But I was also operating in a data scarce environment. I do satellite imagery, apply machine learning in citizen science to drive out to really see what has been the impact of land policies on land cultivation. But also the development discourse is also quite theoretical. It is very practical, and many times we see behaviors and observations that do not always conform to theory or expectations. So if an intervention, for example, was working fine maybe in the north of Africa, it might not necessarily work very well maybe in the southern part of Africa. So it's a very empirical, it's a very practical and theoretical discipline. This subject we are calling development economics, right? So I think that one of the key messages that I want to leave you with is that in those developmental challenges also lie the opportunities. Those development challenges, you can actually flip them and make them opportunities. So I just want to talk about some of them. So the list is not exhaustive, but I just listed a few characteristics of development countries or characteristics of development context. So you find that in developing countries, there is very high poverty, there is hunger and food security, high inequality. Those are just some of them. There is a high marginal productivity of capital, which means that little additional capital can have like a very huge impact, unlike in developed settings. There is also very high unemployment. There are poor institutions, there are imperfect markets. So institutions are very, very important for growth. Institutions are very, very important for economic development. There is a lot of evidence to suggest that the institutions in North America, because when North America was colonized at the onset versus Latin America, it appeared as if Latin America had more prospects than North America. But because of institutions which were established in North America, they are the countries which they are now because of institutions. I will talk more about that a little bit further into the discussion. But what I'm trying to inspire you with is the fact that many of these challenges, many of these development problems, many of them are actually technological problems. Many of them are actually programming, they're actually coding problems, as I'll try to illustrate in a few of the examples that I'm going to present to you. Right, so this is what I've just been saying. Right, so let's look at, so there is this phenomenon which we call the natural resources case. I mean, despite, for example, in Africa, many countries being very rich, despite many countries being very rich, we still find that they've not, achieved, development because of corruption. All these resources, they attract actually negative, factors. But we can think that things like e-governance may actually be able to address this. Then I also want to talk about one of my. I'm not sure I will be able to talk about all the points, but I want to emphasize this. The high marginal productivity of capital, because the starting base is so low. Very little technological investments can have like a very high domino effect. For example, if you invest in a bull, in a plow, and you give that to a peasant farmer in some remote part of Africa, you might actually make a very huge difference in their lives. Whereas if you try and do the same thing in a developed country setting, the farmer will eat the bull and they will put the plow in a museum. So these are sort of the kind of dynamics and contradictions which I think you have to know in the development discourse. Then I'll just also skip and talk about imperfect markets. We've got problems in transport and things like that. But Uber, for example, which is an intervention, which is an innovation, is actually a programming solution to address a transportation problem. So those are just a few talking points that I had for you. We can talk more about it maybe during the breaks and things like that. Thank you very much.
Okay, thanks very much to Wanda and all our speakers for this session. So I think that leaves us with a couple of minutes for questions and opening really a discussion about, what is science for development? Where can we have the biggest impact? So over to you, please shout your question. Right at the back, we've got one.
It seems to me that one of the biggest problems for development in the developing and the developed world is the fact even when the population are highly educated and have a lot of information at their disposal, they elect politicians who reject the evidence of science. we can do all the things that we like at the grassroots level, but is there anything at all that we can do to influence that sort of thing?
Okay, great. Let's keep that question. Is there any other discussion topic? Question to the speakers? Yeah, there's one right here. Yes, thank you, ma'am.
Mine is related to equity. There was a talk about increasing, because in South Africa currently, we've got a challenge of getting women in science, enough women in science. And if we check at the education level, you'll find that a lot of girl learners, they drop out of following STEM subjects because of course of inability to do well in the subject.
So just to read, is it a comment or is your question about what kind of interventions?
Yes, for those that have succeeded in making sure that there's equity in terms of more women in science.
Okay, thanks. Got you. And one more here.
My question is around the ethics of science for development, especially because we see that science has actually brought a lot of civilization and contributed to the good of society. But there are still huge ethical issues that many of those products from science has caused a lot of harm to the society itself. Can Science for Development look into that? Perhaps set some standard or ethical standard when they embark on certain products for societal development through science.
Okay, so Evine, do you want to respond to Women in STEM?
Just that we're working on it full speed, and doing as much as we can. Yes, good point.
And of course, anyone else is happy to respond as well. So Wanda, do you want to take the first question about?
Yeah, so I think the answer lies in our institutions, because I think our institutions, they don't promote, what can I say? They are marketing perfections. Maybe as a simple example, in a rural area, for example, not everybody has got an internet connection. Those are institutions. They've got imperfect information. So an African politician can say, I'm going to build a bridge here. People will like, but there's no river. Say, no, I'll bring the river. So I think it's a question of how really institutions really. That's what I think. Yeah. And the rule of law is for, because politicians can get away with murder.
Thank you, sir. I just wanted to respond to Patricia Whitehouse' question. If I understood it correctly, I didn't hear everything. It really had to do with the fact that politicians, broadly speaking, don't have a good understanding of science, perhaps are anti-science in some ways. That question, whether or not that was a question, is part of a bigger question, a bigger issue, I think, which really comes back to the responsibility that we as scientists have to go beyond our research, our publications, and the like. And that is to engage with the broader public, and there I include policymakers, around developments in science on the one hand, but also what is science? How does it work? What do we mean by scientific consensus? What do we mean by uncertainty in science? So that politicians or policymakers in particular will have a good understanding of what this is all about, though they are not scientists, they're not experts. But when it comes to issues like climate change, for example, they are able to understand what the issues are and to engage with those in a more direct way in developing policies.
Thank you. Thank you, Dan. Okay, we've got a response here. A question?
I believe really that politics is a form of science. That's why in many of our schools we have political science. And my charge is more scientists need to get into politics, because we don't expect, in Africa particularly, we find many people some who read language heading the Ministry of Education or Ministry of Science. It does not really fit. So we should have more scientists get into politics and make a change. Thank you.
Thank you. Anyone brave enough to address the question of ethics and data? Cheryl, if you want to come forward.
Speak with the mic, or speak really loud.
It's just around the question of politicians. And it's a huge topic, which I think we will be exploring over these 2 days, but it's around power relations, competing interest groups. Many people who vote for many of these ignorant politicians are highly connected, are using technology, are backed by scientists in other lobbies, for instance, the coal lobby. So it's really understanding these extraordinarily complex and difficult dynamics. And science is not just win-win.
Thank you. Comment, Fran?
I actually want to respond to the question of
Seriously. Okay. I would like to respond to the question of politics not understanding science. At SASTA, we are aware of such an anomaly. And what we have, because part of what we do is to promote science communication, we have a journalism program. That program actually brings in your journalists and your scientists together in ensuring that issues of science are covered in the media. Because remember, the media is more swayed towards other issues that me and you are of interest, your corruption and what have you. So there's less coverage of science in our media. And that's one of the reasons why our politicians are not understanding science.
Thank you. George, you had a question, then Carolina.
Yeah, don't pull too hard. Yeah, you can just step forward, George.
Can you come forward, George?
Just a very small point, a very crazy suggestion in reply to Patricia's question about the politicians. I think the real key is to try a little bit and give a sense of perspective. And I think the inspirational aspects of astronomy can push politicians maybe in the right direction. And my suggestion is to target not only the politicians, but also the families of the politicians, the children of the politicians. Invite them to observatories, let them look at the sky at night, let them see their lives in the perspective of the life of the universe. And then hopefully it just pushes them in a little right direction.
Thank you. I just wanted to maybe touch upon the question of ethics, which I think is a very good question. Science and the products of science can be used for good and they can be used for bad. But I think we need to remember that science is made and done by people. It's carried out by people, and as such, we can only benefit from the diversity that we have in this room, which is absolutely mind-blowing. But I think we also need to think about the system of incentives, because as people we have ambitions, we have aspirations, we also have failings, and we have needs, and we have. So if our system of incentives incentivize, good attitudes, then science will be used for good. But it's extremely complex and extremely layered. And thank you for raising that. But I think, looking at the system of incentives might be one of the things we want to look at for that. Thank you.
Thank you. I think we have another response on the ethics, and then I'm happy to back forward.
Yeah, essentially, science is not always right. We do mistakes. But the good point about science is that someone else is going to catch that mistake in no time. And therefore, the good thing is that science is collaborative. And whenever there is something wrong, someone else is going to catch the wrong thing. And therefore, we think we're safe from that point of view.
Thank you.
Thank you. What I see as an early career is to bring more scientific in politics. For me, I'm not sure about that because I think it's the politic who change the scientific. It's not the scientific to change the politic. Because, for example, in our country, so we have the problem of reforestation in Madagascar right now. And I know that there is more there is more scientific who know the knowledge at Madagascar who has not been covered by forest, but with politics, with money, so even they know that, so they are to the reforestation. So they know the knowledge of ecology, but they do reforestation. Because, so for me, it's the politics who change the scientific, but for me as a solution, I think we need to do more outreach. Thank you.
Thanks. One more question.
Okay, mine is just a contribution. I think in terms of convincing the politicians, first of all, I think, has there been any study done in Africa in terms of the economic contribution of the different disciplines of science? I'll give an example to say in the UK, they've been doing this, and in the discipline of physics specifically. For example, last year they produced the report that says that physics in the UK is contributing 10% to the GDP and is employing about 7% of the employment in UK is provided through physics. Do we have similar statistics in Africa or in any other country of the different disciplines of science to say this is how much we are contributing to the economy? Because in my interaction with the Department of Science and the politicians and the funders, they ask numbers. That's what the politicians know. What tell me the numbers? What are you contributing? So if we can do that, then it will be very important, especially for SASTA. You know, you have those different tracks to say support for nanotechnology, support for this discipline. Then you can do the science to say how much is nanotechnology contributing to the economy in South Africa? How much is astronomy contributing to the economy in South Africa? For example, in terms of business development, tourism, and other things like that. Those are all the things that you need to take into consideration, the different businesses that are being developed by astronomy, for example, solar, data, and so forth, that are contributing to the economy. So when we start speaking like that, then we speak the same language with the politicians and the policymakers. Then my second question is, has there been any research, maybe from the economics people, to say, in terms of the science that is happening in Africa, this type of science is contributing more to development in Africa, right? To say maybe at the moment, the stage of development in which Africa is, it's more of the biosciences or the physical sciences that are important for development, given by these numbers and these examples. And maybe there will be models that we can take to say, for example, in this country, this is what is more important. So in a nutshell, I can end there, we can discuss more. Right, thank you.
One last comment from the gentleman behind you, and then we're gonna, I think we'll take the rest at tea. Okay.
All protocol observed. What I would like to add, from a city in River State called Port Harcourt, when it comes to the physical money, I don't think we have an issue with that. But the aspect of using data to implement some of the projects that the government do, which is part of what I have been doing, trying to engage the government in using data to make policy. For a very good example, a few months ago, about $400 million was drained in a monorail project that was never achieved. All that money gone because the government couldn't do a survey monkey to know if the citizens really need a monorail at this time. You know, so, but I've decided to shift my frustration into trying to understand how the government think. You know, maybe I've been thinking more as a scientist. So I'm hoping to do a short course in science policy. Maybe that will help me think more like the government than like the scientists. Maybe that way I would be able to present effectively all this data and make the government see that there's need to end waste in using data to make policy and effective decision making. Thank you.
Thank you. Thanks very much. This has been a really great opening discussion. I think we're going to leave the discussion there, and we're running quite behind schedule, so we're going to break for coffee now. But before that, I just want to give to Kevin for some announcements.
Okay, thanks very much, everyone. So it's good. It's good that the discussion is taking off. And part of the plan is this afternoon there will be spaces for you to continue these discussions. So what we ask for you during the breaks, there are big whiteboards outside with the title Unconference Topics. So those are topics that you can come up with here. If you hear something that sounds interesting that you want to have a discussion on, go and write down the name of that topic in one of the blocks. And if you see a topic that you like, just put a tick next to it, right? So the topics that have a lot of ticks, we know that we should, have this venue. Otherwise, there's a few other venues. Otherwise, you can talk in groups outside. But go and write down the topics that you're interested in, and that's what's going to happen after all the talks in the afternoon. So we wanted to do a photo session, but I think this break is going to be quite short. So we'll do a photo during the lunch break, I think. The Wi-Fi, there's an open Wi-Fi called SAAO. If you need to use Wi-Fi, remember the hashtag Science4Dev, and there's an overflow room next door. So you'll see there, we're broadcasting whatever we're seeing on video here is next door. So if you don't like crowds, if you want to have a leg stretch, you can stand next door and you can see the screen next door as well. Okay? Thank you, everyone. We'll have a short break.
Record my 5-minute warning with the stop now.
So you want to check the presentations? Yeah. So which session are you speaking in?
This one. Second from the press. I think we have.
Oh yeah, you can check with Noah. Check with Noah. Which one is? Yeah. Is it that one? Is that the one?
Yes. Yes.
Okay.
This one. Yeah.
Yeah.
So this will be this one.
Yes. Perfect.
This person is also not here and
No, I just look now and I don't. Let's just see which.
Hi.
Sorry to bother you. I just sent you an updated slide. If you can just.
Okay, great. Can you send it to me and Kevin or just to me?
Yeah.
Okay, great. So I can't see which ones you don't have, so I can run around following them.
Yeah, I haven't labeled. I was
Brilliant. Melts out, and the university security is not letting me log into it thinks it's being hacked or something. And I was like, it's only 4 minutes, I can talk about slides, memory stick, I'm happy to.
Oh yeah.
It's not, I think it's only 4 minutes, so I'm happy to talk about
Yeah, if you. Brilliant. Sorry, would all speakers for the next session, if you can make sure your slides are on the computer, all speakers for the next session, please come through. You go get yourself.
I love that.
Quanta issue solved. Correct? Quanta issue.
Yeah, 07, developing a climate response.
Yeah, just along the side. I mean, if you can bring one. But I think now.
I know.
Oh, yes. What's that? Yes.
Where's the charger?
Oh, my battery. It's coming up now.
Hi. How are you, Naresh? Are you fine?
Hi. The mic that's acting up, is it the SA or what?
Yeah, it's just a loose connection.
Sorry? I just want to check.
Good.
I'll
If she
check.
wants to know, she can check
I know there's
Zoom connection if she can test it at lunch.
Sure.
You're not running any tests?
No, at lunch it will be fine. We can close the...
Okay. The boardroom. You did say you booked it all day, right?
No, I didn't book it all day. I booked it from the afternoon. Because there was a SA meeting in from 2 speakers.
Well, just if your talks are here.
Okay. My this one here.
Yeah. Yeah, brilliant. No, it'll help.
Okay. Sorry, I thought you meant the salt board.
No, this board.
Sorry, what's that?
No, before I pick salt out, I just want to be sure that we did.
Okay, but I'm pretty sure I booked this. Is there 2 days of salt board available in the afternoon?
I'll double check because salt is looking for space for the salt.
Send them to the OED. Yes, I think I got it, Jeff.
Okay, Tanya's presentation, I'm going to put it on.
Yeah, you
can I do it?
I should have it here. Should we call them in? Yeah, we can start checking how people are. I don't think.
Oh, come on. Really? Can you not just order it?
Can I?
There's policy at Manchester.
Okay. And she's in the last one, session 4. So let's just see quickly. Session 1, we've got 5, 6, 7. So we've got those before the break.
There's 3 before.
3
5,
before.
6, 7, 8.
Then the next number is number 8. Skill fair.
This is okay, great. No, it's not a flash. This is something else. So do you not have your, okay, we'll just wait until this one's done.
Yeah,
Take-
sure. Yeah. So, Kevin, the participant wasn't actually interested in a particular topic that you wanted to discuss, but there is, I think in the one last talk, there is someone who said something like, he didn't agree with, so he wants to come back and voice his opinion. But
The one that didn't have time to say something.
So he's asking if there is a possibility that we take questions for later on, maybe in the afternoon.
No, I think we have to take the unconference session. There's no other space to.
So I actually let him put the topic in one of the
Good, perfect, yeah.
I think otherwise, I mean, it's a really
Yeah, we're
interesting
not
topic,
going
but
to.
only got 2 days.
So Orota, that's the next one.
Yeah.
So I've got that one. I don't have
We
any
sent
more.
one this morning, eh? Negafax sent it already.
Yeah. So that's 8, 9, 10.
10. Evans, Nyakeri. Are you Evans?
Yes.
Great. So we're getting Evans, and then we need Olaide, whole satellite development. Are you? You Leon. Hi.
Yes.
Nice to meet you.
Ah, Leon. Wait.
I think you already emailed it, right?
So you emailed the document?
Yes.
So do you want? Do you have slides or?
Yes, the slide one. Now I'll remove this one.
Okay.
Okay. There's Evans' talk is on this one.
That's Evan's talk. Okay.
Okay, I'm getting this one.
Is this your USB? That one, presentation.
Yeah.
Is that the one, right? So, okay, and then
That's for you.
there you go. And then this one is Evans.
Yeah, rename it actually to share this. Oh,
Scan and fix?
Yeah, if you don't, it won't work. You know, to get this. You've seen it? Yes.
Prospecting for a
yes. Maybe you should rename it.
Okay, so yours is after Evans. I mean after Orota.
Yeah.
Okay, that's 11. And then
Olaide, I don't have anything.
Afolabi, you don't have. I don't think he's here. I think he's the one that wrote to me.
Okay. So next we need.
Timothy Trami.
Yeah.
Wait, no, this panel discussion has no presentation. So this whole group has no presentations. And then the leg stretch. And then we can go into, so this is number 2, then number 3.
Under there.
Right, number 3. Who's first? Just tell me.
So where's this? I heard Jamal.
I don't think I have Jamal second.
Where is 3 after none? Anuche, Ogu, Margarita Malaro.
So his number?
2. Is this session 3?
Yeah. Okay. And
Then 3 is Margarita.
3 is Margarita.
Mm-hmm.
Okay.
What's it?
Lessons.
Okay, cool. Yeah, we've got your.
Okay, I was just checking because there's a video on the second slide, so I don't know if there will be sound.
Yeah, it should come out
Yeah,
through.
the second slide.
Yeah, the sound should play. Should play. Yeah. But it won't play now, but it should play on the.
Okay.
Oh, yeah.
Okay. It's just for a minute and a half.
Perfect.
Yeah, when we have the HDMI in, it should play.
It should play.
Yeah.
Thank you.
Cool. Hopefully, let's see.
Okay.
So,
Margarita.
Okay, let's just see if we got.
Let's see who's you've got. Yeah.
We can start. So we need 5, 6, 7. So from this one, Silengo.
Silengo, you've got.
Right. That's
5, 6, 7.
5, 6, 7, 8, 9, 10, 11.
Yeah.
Okay.
And the rest we can put on the cloud paper so you can do it as they go.
Yeah, which is the last.
Or here you've got a 20-minute panel discussion on a leg stretch to get
Perfect.
organized.
Perfect. Right. Thanks, man. Can we start taking our seats, please? Hey. Cool. Yeah, sure. I think she's got the keys as well. Yeah, you can just take the keys from her. Yeah. Yeah, that should be fine, I understand. Yeah, you can just leave a few extra ones here, and then if anyone asks, then we'll put it. I'll do it outside. Yeah. So you want to go time?
You want me to? I think we want to follow like everybody. No, there's too many. There's too many.
And then this discussion.
Just check that the discussion we hand over to Mark, the chair and got no presentation. So you've got the time.
So after the presentation, no questions session or as part of this?
There's no questions on the lightning talk.
No question at all. We just go straight.
We'll go straight to the discussion. So they listen and then they will.
So each person's got 4 minutes, and the 1 minute is just to change the slides and to walk up and down.
Okay, welcome back. We are starting. Hello. Okay, we are in the first presentation session where we are going to have. Hello? There are too many voices here. There should be one voice, my voice. Okay, now, that's much better. So we are starting with the lightning talk sessions, and we are looking at innovation for development, commercial, non-profit, and improving practices. And we've got 4 minutes with the timer. David? Yeah. The timer?
Just putting it on.
So we are going to have a timer, and my colleague, my co-chair will assist in monitoring. So we are starting with Sirengo. Please pronounce your names properly, otherwise I'll call you something else.
Okay, this is Daniel. The timer is online. We'll start when you say start. And
yes, tell me when the slide.
Yeah. Okay, good to go?
Yeah, sure.
Go for it.
Good morning. My name is Lengo from the Disaster Management Training Center of the University of Mulungushi. Basically interested in issues dealing with climate change and how it affects communities, and especially the impact of climate change on disaster. So we're also involved in the work for disaster risk reduction.
Yeah. Okay, I'll change it.
Basically, as we may be aware, especially here in Southern Africa, the past two years we've been experiencing extreme weather events such as droughts, and that has actually been affecting the livelihoods of people, and in particular eroding their development efforts. We've been grappling with droughts and poor harvests and infestations of pests, which have of course been eroding all the efforts that these communities have been involved with. And if you look at the SDGs 1 and 2, obviously that are being affected, that are being negatively affected, and that's why we need to start thinking about how can we put SDG 13, climate action, into practice so that we start addressing the issues of poverty, the issues of livelihoods, and also the issues of development for our local communities. And if you come across the concept of resilience, there are basically 4 terms that are used when we're talking about resilience: adaptive, transformative, absorptive, as well as cognitive. How do we make these things a reality for the communities in which we are operating? And this is where we beg the question, what is science for development? Science for what? And science for who? And in this case, we're trying to say, how can we make knowledge and information accessible and useful for the communities in which we are working with? Because science is not important if it's not going to be of any practical use for the population in which we're using. So we should ask ourselves, science for what? And this is where maybe the concept of citizen science comes in. How can we make science real to the people that we are engaging with? We need to have innovations. These innovations obviously are going to promote not only diversification of livelihoods, but also diversification of opportunities for the communities in which we are operating. And most importantly, how do we bridge the science policy gap? Politicians normally look at the 5-year term, and for scientists, we need to look beyond a much longer time frame. We're talking about politicians. Politicians, for them, they may have ideas about science and how to apply it, but for them, they're interested in how are they going to come back in power. So their time frame is normally 5 years, depending on the cycle of elections. So we need to see how do we bridge this policy gap. So the information that we want to take away is like, how do we build this resilience? We're required to provide useful and accessible information. If the information is not useful, then science is failing the communities in which we are we are operating. Science should also provide an opportunity for communities to understand what are the climate risks and how can they respond to these climate risks in order to build resilience for their livelihoods. We should also start thinking about how can we learn and focus on adaptation, transformation, and absorption. And I'm sure we can share a lot of examples from other African countries where all these things are taking place and how science has been used to adapt to the issues of climate change. Thank you.
Thank you. That was lightning. So the time to the first presenter is not available, so we are going to the third one now. The third one, Antia and Regina, they're going to combine those two presents by one person. Regina is going to present first. Is it a presentation? Antia's presentation in 4 minutes. The next 4 minutes, we'll research for your presentation.
Good morning, everybody.
Okay.
Yes, Auntie, I did not know that the time for presentation was 4 minutes. So, that's imperative to socioeconomic development for coastal rural communities.
Press the big one.
Okay. So the highlights are stated. The rural coastal region, the socioeconomic development is the most important, and this has to do with human health and environmental quality. This leads to hazards. So for the coastal hazards, it is triggered by several scenarios: ocean acidification, oil spills, climate change, sea level rise, and the rest. For gas flare in Nigeria, the coastal areas, well, Nigeria, along the whole of West Africa, takes the gold medal. The chronicles and portrays time. This coastal hazard mapping will portray special issues, space, bearing, carrying capacity, and the ecosystem is the one to be really affected. Understanding this can serve as management, as a predictive and intervention tool. Issues driven by scenario-specific time domain. This calls for in-depth knowledge of the coastal forcing as well as interrelationships. So these are the coastal communities. With regards groundwater survey, it's a huge issue along the coast. There is salinization upward. There's much pollution in the water. So the pH of the coastal water is depicted. The number of observation is from November to December 2010. Yes, so all these things, yeah. So the post-extraction deterioration in the coastal groundwater is shown by these figures. And the groundwater, the coliform count is also shown. The post-extraction concentration in coastal groundwater is shown, and then the trend line is placed on the bars. For conclusion, coastal hazard mapping portrays specific hazard impacts and potential to impact, and it provides insight into hazard vulnerability. It's predicated on time elements, while it is predictive capacity provides practical support to contingency planning, which is the basis for human understanding and what have you. Thank you.
This video.
Yeah, that's my presentation. It's on climate change, developing a climate risk framework for West Africa coast. Okay, and the West African coast is very interesting because it's very rich. Fishing constitutes about 40%, and a lot of people are into the trade. And for climate, there has been a lot of issues with regards to degradation. So we are looking at the meteorology and the oceanography coming together, because the seasons for oceanography and climate, are almost together. This leads to perturbations in the atmospheric and oceanographic season. The impacts are huge, and it affects food and water quality, availability, health conditions. So the coast is very vulnerable. Communities are affected, properties and human lives are threatened. We have loss during this perturbations, that is between the oceanographic and the atmospheric seasons. The risks are huge. We've tried to understand the unplanned developments in the area, the vulnerability, the assessments. So when it comes to vulnerability assessment, for example, it has been carried out in Liberia, Nigeria, Benin, and it all adds up to loss of mangrove ecosystem, loss of millions of dollars worth of land and infrastructure. According to the World Bank, unsustainable infrastructure development, inadequate management of natural habitats and resources, and pollution threaten the productivity of the coastal ecosystem. Now, we've carried out some coastline vulnerability, and we know that the coastline are eroding between 25-30 in Lagos. In Senegal, it's between 10 and 16 meters per year. Benin, Togo, that's Lomé, the coastline is eroding at between 10 and 15 meters per year. The strong variability of these sections is linked, because the system that produces this disruption of the coastline is working from the west to the east. So there is no need to look at it, sectorially, but in an integrated manner. There is need, therefore, to develop a climate risk framework that is giving the sweeping global nature of climate change. The risk analysis framework should describe the principles of risk assessment, and this framework should involve identifying sources of potential harm and consequences, which is assessment, evaluate and identify the risks, and create an interactive dialogue, which is communication. So why do we need that? Over the years, we have been approaching all these things sectorial from where the other people on the West don't know what is happening. So we have the World Bank WACA program coming on board, and it is involving all these three aspects. So the success in West Africa region demands collaborative management that apply climate risk assessment principles in a transparent manner. So everybody should understand the principles, the communication should be across, and nobody should be left out. Thank you for your kind attention.
Perfect timing. We are going to have our next presenter, Kifle. Please say the whole name the way it's supposed to be done. Again.
Well, thank you. Well, I think. Let's go. Yeah. Yeah. Well, thank you. I'm very happy that I'm here, joining because of ICSU, to have been involved for the last, I think, 6-7 years now. I'm going to share with you some of the major challenges with landslides in Africa. As someone who has studied his PhD, master's in the developed countries, and working now in the developing country, I could see the challenges there. As you could see on the left is what we have in Sierra Leone. On the right is what we have with infrastructure, for example, in Ethiopia. The next. So now I think probably this is sorry, it's going very fast.
You can use the other one to go backwards. Use the other button.
The 5 minutes is gone.
That one to go forward, that one to go back.
It has to go back.
It's a different
So, I think some of the challenges are really quite very significant. As you can see, this is the landslide in Ethiopia. You have also this from Liberia, recently in Kenya. And this is, for example, in Ethiopia, which displaced more than 3,000 people. I don't know, you have people from Nigeria, especially the southern west. So I have been working in almost all African countries. And then we are trying to analyze what really is driving these landslides. This is in Nigeria, where this main highway was affected, the government started to react because now it became a political issue. So I think let's really honestly ask ourselves, what is really changing now that we have huge slide and other related hazards in this continent? Seriously. So we have been analyzing this and we found out that some of them are very quasi-static, like for example, the property of soil, rock, terrain, characteristics, whatever. But there are a lot of variables that are very dynamic, like deforestation, huge challenge, gully erosion, construction activity, unmanaged, settlements in hilly areas. You have all these that are really driving the problem, and even with the climate issue. But the way how we address our research is completely disciplinary. So we need to focus now from isolated interventions or practices to systems out. Let's see the whole system. And second, we need seriously to move towards multidisciplinary. You can't see this whole interrelated processes, which we need to look at the technical, which is the engineering part, the social and environmental areas. Maybe on the prediction, capacity building networking could be the key, where I'm very happy that ICSU now is with us, who can really help us further. As you could see, even some of our cultural heritage are at risk of landslide. This is a very recent site where this 1,500 rock-hewn church is completely affected by landslides now. I think we'd like to thank all this. And then we need to think of as a system where we see the whole interaction between the landscape, the human, and the climate issues. Thank you very much.
Thank you very much for the presentation. Our next presenter is going to be Julian.
It's better to leave it.
The pointer.
That's a pointer. Let's go to advance the slide.
Good morning again. I'm Julian, and I would like to share our result on how to address some SDGs using green agriculture with bio-input from plant origin.
Just press the big button.
Okay. Why this? Because we want to contribute to some of the SDGs comprised in the United Nations 2030 agenda. And how? How are we going to do it? Our projects aim at developing inclusive and innovative control options of pathogen of various crop and soil amendment using pesticide and fertilizer from plant origin. And how are you going to go about it? The overall method consists of identifying the main biotic constraints of plants, of crops, and then conduct seed treatment for seed-borne diseases and field spray for field diseases using plant extract, and also amend the soil using biofertilizer from plants. And those methods, we measure the impacts of treatment on agronomic parameters, on nutrient contents, organoleptic property of fruits and grains. We measure also the induced biochemical defense system and the growth, plant growth promoters. We also measure the soil physical-chemical property, the nitrogen release and nitrogen use efficiency, and also the beneficial, soil-borne beneficial microbial load, and content in heavy metal and pesticide residue in soil and fruits. And as a result so far, seed treatment and plant spray using biopesticide combined to soil amendment with biofertilizer. First, we saw the improvement of agronomic parameters, the organoleptic and biological property of some proximate composition of fruits and grain, and importantly, the increase in yield from 20 to 400%, and then the increase in storage shelf life of vegetable from 40 to 69 days. That's the okay. These are some figures of we have some. We have here yield increase of 400% of treated maize from the treated plots, and here is the control for maize. For soybeans, you have here increase of 155% from treated plot. And here you have another variety of soybean, the clandy. You have here bunches of flower from treated plots, and look at the light flowers from the non-treated plots. And all the results, if you have found, you could adjust 11 SDGs. The second part of results so far have shown that the kinetic of mineralization of biofertilizer amended soil is primary mineralization with improvement of pH up to 6.5. And this means a congestion dynamic which implies nitrification phenomenon. And we also notice improved in annual for about 90%. Okay. And the fruit from organic plot revealed traces of copper, whereas content in organic amended soil was reduced by 40%, indicating possible use of bioinput as carrier of heavy metal. And also organic amended soil includes some biochemical fertilizer indicator such as fungi, nitrobacter, and azotobacters. And we have here nitrification from soil amended with Titonia diversifolia, and then you have here the nitrification from NPK. You have here traces of copper from tomato crop with bio-input, and here from synthetic pesticide and from farmer who use a lot of pesticide and synthetic fertilizers. Those results will address 5 SDGs. Thank you for your kind attention.
Thank you. Our next presentation is going to be Leon.
Good morning, everyone. My presentation here is technique for wildfire detection and monitoring using satellite remote sensing. Introduction. Forest fire have been increased in severity and frequency in recent years globally. Fire causes many problems such as property and vegetation damage, and increases in local air pollution levels. Satellite images facility mapping of Bani's region and determination of Bani's severity. Benefit of using satellite imagery: more accurate post-events delineation of wildfire extent. Small area affected by wildfire can be determined and assessed. The information. Go back to the other button. The information obtained can be used to carry out risk assessment of affected and surrounding areas. Satellite images data collection over time can be used to monitor environmental recovery, especially in relation to agriculture and forest. How to process a forest fire mapping. First of all, you need to download satellite images from the portal, maybe it's Explorer or Sentinel Hub. You can identify the area of interest, and then you can download the satellite images. Number two, you can process it. You can do some pre-processing and processing of the image of the body severity mapping, whereby you can do some NBVI or NBI, normalized bind ratio. These are some images when you get from before fire and after fires break. So number three, you can calculate the area, burning area from the classification. Then you can calculate the polygon area. Then you can create a shapefile. Then you can calculate the total in Excel. So conclusion, remote sensing of burn severity is possible. Detection of temperature anomalies is possible using multi-temporal image analysis. On the ground, burn severity information can help calibrate remote sensing burn severity estimates. Pre and post-fire image characteristics are important. Further validation or accuracy assessment of the multi-temporal algorithm using ground data from different locations. The validation scheme may be improved, especially when modifier product is used for validation. These are some reference. Now you can also view some global fire in near real time. Yeah. So this is a platform where you can search at any country. Then now you can monitor fire in real time. Yeah. Does it need to go? No. Okay. Thank you.
Thank you so much. Our next presenter is Ivan. Do we have Ivan? Oh, yeah. Oh, yes. Okay.
Good morning.
Oh, what happened there?
Counting my time.
I'll restart your time. What happened there?
Should we set the timer?
there's your timer starting it.
Yeah, my name is Dr. Nekeri. I'm presenting on behalf of my other colleague, Professor Monica Yeko, and this is the topic. Now, I'm from the Africa Center of Excellence in Sustainable Use of Pieces of Food and Feeds. This is an Africa, World Bank supported center in my university, Jaramogi Oginga Odinga University. And we are also prospecting for students from across Africa. So if those students who are interested and who can be supported on a scholarship to study here on the area of use of insects as food and feed, then you can contact me. Now, for our introduction, we realize that there is a lot of food nutrition in Africa, and that is one of the headlines that are in my country about food insecurity. Now, the eating of insects, however, is actually an African culture. That is a publication by one of my professors, Professor Monica Yeko, has done a lot of research in this particular area. You can be able to see how they are being harvested. The main method of collection of this particular insect is usually from the wild during the time that they emerge naturally. You can be able to see this particular diagram here. You can see that the lady is actually collecting for the family, but the men, you can see they are collecting for their own stomachs. Huh? Now, because of the widespread food insecurity, the egg-borne insects are actually being considered as a mainstream food alongside the plants and other animals. If you go to most markets in my area and other neighboring countries, you'll find that they are actually a commodity on sale, just like any other beans and any other components. This is a picture depicting the grasshoppers being on sale in Uganda when they emerge in season, actually. Now, this is because they have a lot of basis, scientific basis, so you can be able to see a lot of nutrients. Now, the concern, however, is that most of this particular collection is actually from the wild. Now, because of climate change, there is unpredictability in the emergence of this particular edible insects. Now, this has rendered the traditional method of predicting emergence inaccurate and has resulted in sporadic and predictable occurrence of swarms, which we know if they occur in very large numbers have the prospect of actually causing food insecurity because they eat crops, ravage fields, and put livelihood and food security at risk. Now, for example, in Africa, within my area, there is a lot of swarms from the desert locusts at the moment. This has been reported in about 8 counties in Kenya, and these are the headlines in my country, or where they have been vetted. Now, the current mitigation measure by the government of Kenya is by spraying, aerial spraying of this particular swarms of locusts. However, we know this is not preventive, as this is kind of firefighting. You're managing a crisis, and therefore that is necessitating the use of those advanced methods like the chemicals, some of which are actually not registered in my country. And just because of the crisis, the country is actually experimenting on them. Now, the cost of doing that is also very prohibitive. Now, we think that we should look for a better method of controlling this particular crisis, and we're proposing that we can use astronomy that uses remote sensing technology to predict the occurrence of this particular edible insects for more preparation of mitigation measures. This is because we are thinking that if we use remote sensing, self-effective surveillance technique, then this is a preventive control strategy, and it can be provide essential information on the development stages of the different insects for on a real-time basis. Now, this then can be used for actually preparation, for example, preparation of methods for harvesting them for onward processing for food and feed, for mitigating food security, as we say. Now, we think that if we employ this particular method, the basis for proposing astronomical remote sensing is as follows, and we think that if it can facilitate harvesting that can be effected by means of aerial tracking strategy, if we can be able to predict when and where they're going to occur. Now, these are the various forms in which we can be able to use the edible insects, and those are the innovative methods. Thanks to all. I have a product sample of what we have prepared at my university of this, the use of insects as food and feed. And we are interested, and I'm requesting for permission from the organizers that during the next tea break, you can test it.
You should have brought a lot for everyone.
Yes, I did.
Thank you very much. This is about December. And the next presenter is
No, I don't
Afolabi. Do we have?
We don't have a presentation for
that, but is the person around? Okay. Now this presentation, I want to go into discussion. you're seeing what they are doing, and you have to call them, drag them aside, and tea and lunch, and have a discussion. Now I'm going to call upon Martin to come over and hurry your troops so that we can have a session.
Thank you very much. We now continue with discussions looking at how we can use a multidisciplinary approach to achieving our sustainable development goals. I'm not going to introduce my panelists with their full credentials. So all protocol observed with that. We've got a wide array of SDG contributions from our panelists. Sunita, could I ask you to come up, please? Sunita focuses on farmers' climate resilience and therefore focuses on the aspect of food security. Alberto, could you please come up? Alberto will be giving us a perspective on capacity development and therefore looking at education in terms of SDGs. Olumiwa, could you please come up? Olumiwa focuses as well on science for suicide prevention, something quite interesting there, using artificial intelligence and computing power there to contribute to the health discussion. So now, could you please come up? So now has a focus on astrotourism, something quite interesting where she innovates on creating livelihoods and therefore reducing poverty within the context that she works in. And last but not least, Timothy, who also focuses on capacity building, which is going to be quite an exciting conversation that we're going to have here. Can you give my panelists a round of applause, please? I think considering the SDGs and working towards them, there's been a lot of talk in the morning about not just ticking the box in terms of sustainable development goals, but actually doing and applying within a community. Science for who, science for what, and science way. And I think we have such a great panel which has practical applications of how they've actually used science within different vast array of communities, various factors. I'm going to start off with the capacity building specialists. I'm going to bring you in here, Alberto, to just give us a background of the work that you do in terms of the training of engineers and innovation in that aspect of capacity building.
Thank you. Do I also have 4 minutes or?
No, it's up to the chair.
Okay, thank you very much. In fact, what I wanted to bring here was the influence of the industry-academy relationship for the quality of the engineers training. And I'm not bringing new facts. I'm only trying to bring questions for reflections and see how can we innovate to make the negative points of this relationship become positive. In fact, we all know that collaboration between academy and industry has both positive and negative impacts, positive and negative, practices. All of us, when we think about it, we think about resources, financial resources, and also what we would think RD&D, something that is related to what we are discussing here, science for development. But I think that in most of cases, we don't think about the science development, which was the discussion in this morning. We think about science for development, but not science development. And why I'm saying this? Normally, the academy and the industry have different targets, different goals, and these goals may meet or not. The fact is that when they come to us, they demand something that is their own interest. It's not necessarily our interest, but they bring resources that we need. So we get like kidnapped by the industry, and we tend to forget about the development of science, which is much broader than the science for development. From my perspective, the science for development is part of the development of science. As was said this morning, at the end, the development of science may turn into science for development, definitely. So the question is, First, when we think about this relationship, normally we tend to think about research and not about lecturing, not about training. And sometimes we have the most experienced people working for industry and research. And these professors leave the lecturing for their fellow assistants, their young men who are not really experienced enough to train properly the engineers when we talk about engineering. So because of this, I think we get some kind of problems in which we get top funding, but then we jeopardize our own goals, our own role. So the point is, how can we do the engineering of this relationship in order to make sure that we gain in both sides? Because in fact, we do need the industry to work with us. The industry needs us, but we cannot simply forget our main role, which is training and developing the science. I think this is good enough.
Great. I think it really ties into our next speaker, who we were talking over the break about how you've been innovating on training as well from a higher education perspective. So it's great that we start the discussion from that level of informing higher learning institutions, industry playing a role there, as well as the education responding to the needs of the society, and how have you been innovating on that aspect?
Thank you very much. What we are doing, the question that we are asking ourselves at the National University of Lesotho have been, how can a university be directly involved in job creation? So what we realize is that most universities use a traditional approach in which they focus whenever issues of IP, intellectual property, are involved. They focus mainly on invention, which is just a small component of innovation. So at the university, we have a huge potential of young people, and this is where knowledge is created. Therefore, this is where innovation can thrive. But if we focus on invention alone, which is a very long process that has to be patented and all kinds of things, you delay the creation of jobs as we wanted to do. So what we did was to develop what we call a university innovation ecosystem. So we look at a research level, at a laboratory level, we look at research that has potential for commercialization. It doesn't have to be something new. It just has to be bringing a solution to the society. Then we have created an incubation space where we turn those ideas into businesses. And then we are also working on mass production of those products. At the moment, we are working with around 100 startup businesses by our university. Some of them are already well established in the markets. They are producing products that the markets need, and we are creating lots of jobs as a result. And we have what we call an University Innovation Hub, where we actually bring some of these startups inside the university environment. We incubate them for some time, we support them with money, knowledge, funding, and all kinds of things to make them ready for the market. We also have an outreach program where we tell the society all the innovations that we are doing at the university in a very simple language that they can understand. Our research, our Facebook page reaches on average of 200,000 people every month, not only in Lesotho, but regionally within the SADC region.
Thank you so much for that. I'd like to bring in Sonal here, who has been quite innovative on astrotourism and creating livelihood, as we've been talking with the theme of creating sustainable jobs. Could you kindly just share with us what your area has been in that aspect?
So, So our enterprise Global Himalayan Expedition has been working with remote areas to electrify them with solar energy and provide clean energy access. But that has been just one part of it. We've been in this area for almost 8 years now, and what we have understood is that if you want to create an intervention, a development intervention specifically, you also have to ensure that you create an ecosystem for that intervention to thrive. Merely putting one telescope or say merely giving light using DC solar microgrids is just not the end of it. It is just the first step, and you have to ensure that it is self-thriving and the communities are able to sustain it even when you move out of the equation. Because obviously you are not going to be in that region forever. You will have to ensure that you have developed the skills of the community, you have ensured the capacity building to an extent that there are spin-offs from the intervention that you've done. Taking the example of the astrotourism project that we've implemented in Himalayas, we actually started with electrification. That itself is a very long process where you identify and serve the villages, and then you build community engagement, which again is a time-taking process because you're required to build trust. It requires a lot of patience, and once you assess the needs of the community, once you know that what is it that they require, you design and tailor a solution based on that. One single idea cannot have a universal application. You really, really have to tailor it down to the area and the community that you are working with. And the area of Ladakh where we work in, we were really fortunate that it's a high altitude area. It has some of the planet's best skies, and we thought that we could actually bring in the astronomy intervention, and that's how the AstroState started.
Thank you so much for that. I think we'll bring in the conversation about food security here and creating solutions to ensure resilience amongst community members based on climate changes. Could you please speak to that, Sunita?
Just that little thing is a little bit loose.
Okay, all right, thank you. As we know, climate change is affecting every sector of our lives. In particular, agriculture and of course then by extension food security is most heavily impacted, and more so in developing countries and elsewhere. Therefore, it's very important for us to be able to give our farmers techniques and methods where they can adapt to these changes and make the agriculture more what we call climate resilient. Now, climate resilience means allowing farmers to earn their livelihood, but at the same time adapting to these changing climatic conditions, but at the same time reducing their contribution to the greenhouse gas emissions. So it's a whole approach known as climate smart agriculture. Now, climate smart agriculture is not new per se, but it's a different approach. It's a different way of doing things. It's an improvement over what exists, plus some innovations brought in. And myself and my team are working on developing these kind of sustainable technologies to make agriculture more climate resilient. So it's innovative, but it's also an improvement on existing technologies.
And lastly, Olomiwa, could you just explain to us the multidisciplinary nature that you've taken in terms of applying AI principles and medicine principles to address issues of suicide? And probably you could give us a contextual background as to what actually influenced the project that you're doing in terms of mental health, combining technology and medicine.
All right, thank you. The traditional methods that we've approached the suicide prevention project that we're working on has been to let people know about the warning signs of suicide, hopelessness, lack of sleep, bipolar disorder, and many other warning signs. Now, we've gone to schools to explain, to train people on how to identify this particular warning sign. However, we found out that it is also possible for us to innovate on the methods that we've used in the past. For example, we introduced the life skills education. Now, life skills education talks about the adaptive skills or adaptive behaviors, positive behaviors that people can make use of when they face challenges. And we believe that if we equip them with those skills, they can use them as the bridge to cross to the other side. For example, communication skills, effective communication skills. For example, coping skills, and something we call decision-making skills. We found that sometimes when people commit suicide or make a choice that I'm going to end my life, they lack the expertise, or let me say the skills, to do what we call critical thinking, to make a kind of understanding of what are the options, alternative way of solving a particular problem. So we introduced that. Now, to the second level of innovation that we are so concerned about now, or that we really want to take on, is the application of the power of machine learning, artificial intelligence. Now, we believe if we can take the medical data of patients, or let me say customers who come to the hospital, for those who come to the hospital, we can pass algorithms into this particular data that has been collected, so that early prediction can be made, so that whosoever that is identified to be exhibiting signs of suicide or mental illness, they can be attended to even before they commit that particular action. Now, we've collaborated with an organization, an academic organization called Obafemi Awolowo University in Ile-Ife, Osun State, Nigeria, Department of Mental Health. Now, what we discover also that we lack enough power skill, or let me say human skills for individuals who can help us solve these problems. And that is why I'm hoping that an effective collaboration can be made inside this particular workshop with some of the individuals that I've listened to, who spoke that they are also working in areas of machine learning and artificial intelligence.
Thank you for sharing on that. And I think you're bringing us into our next theme of focus area, multidisciplinary approaches, looking for funding, challenges of getting people out of their silos to actually work together. I'd like members of the panel to have discussions about what challenges have you come across in working for innovation towards development? Because it's an array of projects, multi-stakeholder, multidisciplinary. What challenges do you come across? In what ways can you guide people on overcoming those challenges, from the education sector to the community sector to the mental health sector? And I think he started well with it, with the need for collaboration in ensuring impactful work that you're doing. So I'm open to the panel members, for anyone who'd like to give us the challenges that they faced in their context and how they've managed to overcome them.
I would like to start with the issue of funding. In our case, we thought that when we began engaging on this issue, because unemployment is a real problem in my country, especially for university graduates, we thought that obviously the government was going to be interested. Here are people who are now finding solutions. But, you know, I think there's the same situation throughout the rest of Africa. You have a government that are more interested in funding sports and music, but never science. Not that there's anything wrong with sports and music. But, you know, science can make a huge improvement if we can fund. So, ultimately, we came up with a solution that, you know, instead of making long proposals for funding, which are very time consuming, we started doing what we call a media outreach, especially within the country, so that people know what we are doing, so that they could support it. Almost on a weekly basis, we are on social media, we are on Twitter, Facebook, and we are on local newspapers. And for some reason, we ended up attracting funding, not from the government, but from the private sector. Because now the private sector was seeing the university trying to solve their business problems. In the space of 5 years, we have been able to attract 10 million into our 10 million rents, not US dollars, into the work that we are doing. We have been able to build facilities for the incubation and fund the startup businesses that we have.
Yes, I agree. Funding is a big issue. Although having said that, especially for research and education, there are lots of funds available. There's a huge amount of money available everywhere. There are lots of funding bodies, there are lots of donor agencies. However, as my friend said, it's not easy to tap into them. It's very competitive. I would like to stress on one particular aspect which may or may not apply to everybody. And that is this new trend, especially in some donor agencies, that is they ask for co-financing.
So they give you a certain amount, 80%, 90%, 70%, and then they insist that you provide the rest in cash. It can't be in kind. Now, when you're talking about developing country projects, this becomes very difficult. It's like you're giving somebody a car, and then you're saying, okay, we'll give you the car, but it doesn't have a steering wheel. You put the steering wheel. So if you're giving something, you're giving funds, please, give it complete. So giving and insisting on co-financing can be a big constraint for many of our developing country institutions. So that's one issue. Specifically for agriculture, it's not easy to get private funding. Unfortunately, private companies, private sector not interested in agriculture except if it deals with high-tech, biotech kind of agriculture. Otherwise, they're just not interested in the normal day-to-day food security issues. So funding is a major issue.
Anyone last comment on the challenges?
Now, in my field, we're talking about suicide prevention. I went on Google Hub to look for applications probably that have been created by people, and I saw a lot of applications that have been made. Now, sometimes when you download these applications on your phone, you later find out that it's not actually solving the problem. Now, I want a kind of a central place where there are sure answers, where there are sure solutions that, because suicide is not something you can just wait and look, let's just wait. When you see someone who is exhibiting the sign, you don't postpone action. You have to take action quickly. So there is no time for us to be experimenting with an application. Oh, this one doesn't work, I take it away. That one doesn't work, I take it away. So I believe it would be good if we have a database, or let's say a repository of solutions, as in time-tested solutions that people can access on the spot without guessing all around, without trying many solutions before you get to the right one. So I think it's good that as scientists, we share best practices that are working in our respective fields.
And bringing us to the final aspect of our panel, because I'd like to open up for just 2 questions for members from the audience. What are the best practices? What have you learned over the years in innovating for development, in innovating with the community? And what is it that people who came here can take away and learn from the different sectors with a multidisciplinary approach of ensuring science?
Okay, well, I think the first would obviously be like thinking out of the box. When you're talking innovation, the first thing would be thinking out of the box. I don't have to elaborate on that. We all know you have to think of the box. You have to look out of the box. You have to think of new things. But I would say, and especially again in agriculture, this is very important. Don't look. I mean, I wouldn't say don't look. Yes, do look forward, but also look backwards. And there's a wealth of indigenous knowledge in every field actually. Okay? And so we should not ignore that. We can learn a lot by looking backwards at what our forefathers did. So that's the indigenous, the traditional knowledge, which we can then adapt to our modern needs. So my advice would be look forward, yes. You might even say look laterally if you wish, but also look backward, which we often don't do.
Yes, I also had an experience on what I would call multidisciplinary research proposals. Sometimes they are much, I'd say, fundable than the single area research. An example that I have from my country is a research project within environmental, energy, and health areas. I never thought that one day I would be in such a team where we are dealing with energy, environment, and AIDS. But then when we set up a project like this, we realized that there is a lot of common interest that can be combined and then really make an impact that makes the project very well seen for the funders. And this, even from the government, we managed to get something. Because for the government, health is very important. But if you say environment, they'll say, okay, we will come later. But then if you combine everything, then it becomes much easier to get funded, even from the government, private sector, and others.
Well, wise men of the past say that a journey, starts usually with a step forward, but take it from working in the development sector for 8 years, it usually starts with a step back. When you step into the development field, you really have to leave all your hats of experts and whoever you are back and actually sit with the community and learn from them. It is not just, and what we have seen is that the problems are not always technical. You have to look at development from various lenses of political, social, cultural. There are so many aspects and so many layers that are embedded, and you can only get to the bottom. You can only get to the critical mass only when you explore and peel off all of those layers. So to ensure that your projects are sustainable and they are self-thriving, community participation is really, really critical, and that really requires a lot of patience and a lot of trust.
For those who want to get into this area of using innovation for creation of jobs in the academia, I've learned two things. One, academia has a huge potential to solve problems because this is where knowledge is created and is concentrated. However, we are more worried about publications than solving the problems of the men on the street. That is where the problem is. Secondly, we often tell our startups in the universities, even when you think big, but start small. Be willing to start with what you have, and then resources will follow. That's what we have learned over the years.
All right. One of the things we take into consideration about what we do is to empathize with the people that we're going to give our service to, or people that need our services. I think it is important for us as scientists that we show empathy. We put ourselves in the shoes of people that are going to consume our products. The other time, someone was talking about the ethical challenges we face. We believe as we make use of our scientific knowledge and ideas, we want to ensure that there is safety for people and there is peace for people that will make use of our products or our services. Thank you.
Thank you very much for sharing on your experiences. For the last 2 minutes that we have, would anyone like to field the question to any of our panel members? If your voice is audible enough, you can also stand and give it a shot.
So mine is a comment, but I wouldn't mind to respond to the comments. My comment is about the issues of climate change. I think the problem that I see is that we have become crybabies of climate change. Just complaining about climate change, and instead of addressing climate change, we have allowed climate change to address us. So instead of addressing issues that are causing climate change, we are just responding to effects of climate change. You will have, for example, a politician who says we are being adversely affected by climate change and we need to address these issues. And then that same person goes to give plots in the catchment area for water. So I think sometimes we are not very serious in mitigating climate change. We have to find ways of mitigating the propagation of climate change instead of just addressing the effects.
One more question or comment before I close up.
Something that a platform like this and I think we should we also need to do some mention regarding policy engagement, science communication for policy engagement. Very important.
I think this year there was the World Science Day for Peace and Development, an opportunity for scientists to articulate what science is about and how much impact it can have on society. I don't know how many of us do celebrate that day and make themselves available on TV and radio stations, talking in native languages to the populace. I think someone also mentioned open science. Very, very important, putting the stakeholders at the core of all our proposals. Also thinking about how our science is going to land on the community. I think this is very, very important because the funders themselves, I think NRF is here, I don't know who else is here, can think about how they position the cause and how they measure impact to make sure that they propose us, think of the theory of change and how they can articulate how they do the impact. I think the gentleman from Lesotho said something very, very profound, something that I'm passionate about, how to make these university industry linkages. You'll be surprised how difficult it is. The interfaces between us and the government, very, very, very small. We need to make sure that we open these conduits and make sure that interesting problems come from society to us. And obviously, we have to make ourselves available. So I'm very, very keen to discuss with you some of our experiences in this regard. So I thought maybe I'll comment on those two.
Thank you so much. Two very last concise comments before we move on to the next session.
Thanks for the opportunity. I'm actually thinking on to what you said and what you said lastly, that actually there is a gap between the training and universities and the industry requirements. Coming from the university, from where I come from, the country where I come from, there's always a complaint from the industry that we are releasing graduates into the market who do not have the multi skills of what the industry requires. And perhaps this is because of the promotion criteria, which is say we are more interested in publications rather than the real skills that are going to impact the industry from these particular graduates. I think the central body for promotions has put more weight on publications than other things rather than skills that the professors or whatever have on industry. We should have experience. We should recommend for a policy change. Say that one of the considerations for promotion for maybe as a professor, senior lecturer, should be that you should have proven skills in industrial links. Say that now we can put more emphasis. Otherwise, we'll be just using yellow papers to teach and doing publications in order for the sake of promotions. Thank you.
Very last. I know there are a lot of other questions. I think over break and tea time, please feel free to reach out to any of the panelists. They'll be very happy to field any questions from you. I know we're running a bit late, and so it's the very last question of the session. Comment.
No, just a quick comment that I think it would be good to think, especially with the people here in the room, what can astronomy bring to the table? What can students, young people trained in astronomy bring to your projects, your concerns, etc. Don't have to answer now, but hopefully by the end of tomorrow, we are going to make a little bit of that bridge, because I think that is really important. What are the skills that are important for you? I think we would really like to hear that from you.
Thank you very much to our panelists. I would like to give you an opportunity to answer them over lunch, because I know there's a lot of comments that came which you would add real good value to on the importance of society, the importance of creating that engagement between industry, society, policymakers, and the community to ensure sustainable development with whatever it is that we do. Thank you for your time, and please do connect with people over lunch. Thank you.
Guys, it's not lunch yet. We have lunch. We're excited. We have one more session, but there's a 10-minute break now. So I'm going to put the time on the screen, and we'll start again in
Make it 5 minutes. Come on. No, if you make it, if they go out, they're gonna.
Okay, 5 minutes, Kevin's next.
No, if anyone goes out, they're not gonna come back. So, okay, never mind. Oh yeah. Don't think about these things. Hey, Grandpa. Nice to meet you.
Nice to meet you. I think I have to remove one slide from my presentation.
Sure, come.
I don't have enough time.
Yes, Anka.
For Bonaventure.
Sorry?
Bonaventure.
Yes.
Slide.
I don't have his slides.
I have it.
Okay, okay. Give me 1 second. That one.
You found it, Mike?
No, no, I don't. If you can give me, it's not in my email.
No, I sent to your email.
Now? Oh.
Yes, 15 minutes ago to Vanessa's email. But anyway, yes, I bring it.
Didn't come through.
Get it.
Grandpa, yes.
Yes.
Hi, Neeraj. I'm reducing by one slide. We'll make it otherwise.
Yeah, so as you know.
You can ask Vanessa. Is it on the? Yours is for the next after lunch, right? Okay, let's do it at lunchtime. Okay.
So as you notice, my panel, everybody will give talks.
Yeah.
For 4 minutes each.
Yeah, I can do the time.
Yeah, and then we'll have a discussion.
Hello. Yeah, let's do it at lunchtime. Let's do the ones after lunch at lunchtime. Yeah. Cool.
I think Bonaventure's going to be after lunch.
If it's after lunch, we'll do it at lunchtime. Yeah.
Okay.
Where's Jamal? Hi, Kevin. Hi. Ah, check it out. How are you? Happy to recognize you. Oh, good. Hey, Patricia, you looking?
Is that doing anything?
Yeah, it seems to be, the stream seems to be working fine. You can see the overflow room. The overflow room is basically taking the sound from the stream. Yeah, so you can have a look at the. Yes. Is it before lunch?
Yes.
No. He's out of the program. No one told me. When he told me that he wasn't coming, we took him off the program. Yeah, sorry, man. Yeah, that was a while ago. That we. It was a while ago. As soon as when he told us that he wasn't coming, then we changed the program. No, he didn't say. Sorry.
Can you find it? Maybe you have come through. But anyway,
it's not on my email. It didn't come through. Maybe.
Yeah, this thing. The usual email I send it to you. But anyway, yes. It has come to America and didn't come back yet. Some server.
Yeah. Insert the last.
This is the last.
Is that one?
That's right.
Okay. So, don't worry about the microphone. Like if people ask questions, this mic goes halfway up the room. They can walk halfway up the room. It's too complicated to go. We'll still have to test it and all that. So don't worry about it. There you go.
Okay, oh yeah, I'm going to put the timer on my iPad. I wonder if I can do that. Where's the HDMI cable?
Wait, for what? You want to put the timer?
Put it on so we know when you're starting.
Oh, when you're starting. Hi, Joshua. Hi. Lady. Are you in the next section? After Margarita, yeah. What was the name of your Pragsac? Yeah, I got it. Yeah, it's here. Thanks, man.
Oh, there goes my phone. market.
Zachary
I think
Cam
we
didn't.
five now, right?
I don't have camps.
He's here, shall I get him?
If you can see him. No, it's fine. It's fine. He sent it. I don't have a talk for Michelle Willebrands.
She did email it.
Okay.
Just say Michelle, and don't, maybe she sent it from your Gmail. No, just don't put the email address, just say the name.
Science4Dev. Yeah, this is the one, right?
Yes. Yeah.
Okay.
So there's a timer for them as well, right?
Yeah, I'll do that.
So you don't have like a fire engine siren at the end of the 4 minutes.
We'll have to rely on you as the panel.
Yeah.
So Michelle, then Segla. Oh yeah. I don't think I have. Let's see.
Wait, I'll tell you who are all there.
Segla.
No, you had it just now, right? Segla also sent it yesterday. Yeah.
That one.
Yeah.
Then Lucia.
So can I give you the order, or shall I read it out and you can just?
Yeah, we can do that now. I just want to make sure I got. Now who is this? This was Michelle, so I did have Michelle. Anyway. People don't label their thing. Anyway, now I've got two.
Okay.
Right.
So the first is Lucia.
First is
Machete.
Okay. Next.
Next is the font Segla. Amy Segla.
Okay. Yeah.
Then is Michelle Wilbrand.
Yeah.
Then Nadeem.
Okay.
And then Ranpal KG.
Done.
Okay?
Right. Yeah. Just check there. There's the order. I'm ready whenever.
Okay, great.
Segla. This is Segla. No, Machete.
Machete. The next one is Segla.
But it says Western
1 minute.
Cape.
And then we see.
He's from Benin, no?
That's the one.
Oh, okay. He's from life. Okay. And then Michelle.
Yeah, then Michelle, then Nadeem, then Ranpal. Okay, cool. You can, they can hear outside. Oh, you did. Sorry. So, how are we looking in time? 12:45.
We're still half an hour late. Well, not quite. 12:25. It's only 12:45. 20 minutes.
12:25.
So it's lightning talks now.
20 minutes, yeah. Okay, so I've got all the lightning talks. Which is the one that's always on top?
Okay, welcome everybody, welcome back. Plug that in. Jamal, are you coming to the front? I'm here. Excellent. Okay, everyone, we've got another session of lightning talks followed by a panel discussion and then lunch. So thank you, Jamal.
Thank you. Yes, actually my presentation is rather unpretentious. It is about linking two worlds which seem to be separated, distended, which is the outreach world and the academia, through successful experiments, possibly I should say, which have been taking place in fact in Nigeria. And I call it balancing the academic act with outreach action. So I wish to bridge or to outreach, to do the bridging, and it has been actually, well, what is that? Yes, so
sorry,
I
I'm
was
just going to
talking
share.
about.
Sorry, 1 second. I'm just going to.
Yes.
I just need to share the screen.
Okay.
Yeah.
Keep my seconds straight. I mean, don't drop anything. My capital, my little capital. Good.
Okay.
So, yes. Science, the outreaching is an important act, in fact, for any scientist who, I believe, respect himself and who want to do work in the society, because it is the working of science. It brings the working of science to the society, and in fact, for astronomy, what's happening? It brings forth, of course, the excitation of the cosmic picture, and it's also a rampart against irrational thinking. So it has an important social role, and it was said this morning by Van Bishop, our president of IAU here, that science can liberate indeed. So that's one part of things. Yet, well, I am going to be giving up on that. Okay. No, I'm going the other way. No, the other way. No, I almost finished. No, I finished. I'm really sorry, but you have to get back to the first slide.
This is the next.
How you go? You go right. Okay. So. Give up. No. That's it.
Start again.
Okay, let's start again. So, indeed, science can liberate. That's one thing. Now, I'm going to, in a few minutes left, 1 minute more, please. We're going to talk about this intertwining of science activism and in academia, and in particular in astronomy. It was an experience which brought together astronomers, Algerian astronomers, and various universities who do not know each other through outreaching, and they end up creating academic programs. So that's the various activities that were carried out with those people who more or less didn't know each other in various, in universities. We brought them into activities like festivals, astronomy festivals, various programs throughout Africa, a radio program, and so on and so forth. And we ended up, this is some pictures, we ended up creating, after 17 successful astronomy festivals, a master of astrophysics, which brought them in one location in Constantine, in eastern Algeria. And they are people from, again, teachers where, that's my last, well, anyway, so let's go back. When I go, sorry, I just
the bottom one to go.
Bottom, okay. And even in the context of the AIU 100, which was celebrated last year, a few days ago, we finished it. It was quite easy to bring these people to bear because, in fact, the foundation of the committee, national committee, was done at an observatory in Algiers, and you see it's a good mixture of professionals and amateurs. They were all brought together because they knew each other through outreach, and so we did successful programs on TV, on different things at the universities and so on. So it's just, as I said, a modest example of how outreaching, doing work for the society, for the people, can bring interesting development in making the astronomers get together and create a successful program in astronomy. That's all I want to say. And that's the time is my time is off. Thank you.
No, just please just put that. I'm going just to make them go through. That's all. Is it public advertisement? If you can, it's okay. No, okay.
That one?
Yeah, just go.
Yeah, but I've got to load next one.
No, it's just defined. Okay, that's fine.
And it was my few seconds which were taken out from my.
No, okay, you finished. No, just take few seconds. Four seconds.
Sorry, do it.
But it's okay, fine. I wanted to do it. Just a few nice pictures. That's advertisement. Okay, go. That's my country. That's something that we are doing. And that's my last slide I wanted to show. Thank you.
Onuchi is up next, and he'll tell us about a project in Nigeria.
So it's front, back, and pointer.
Front, back.
Okay.
Good afternoon, everyone. My name is Onicha Ogu. I'll be doing a presentation on astronomy for development using the IDP Children's Astronomy Outreach Project as a case study. This project was done using astronomy as a tool to counsel, heal, and inspire traumatized children that have been displaced due to ethno-religious conflicts in different places in Nigeria. 4 minutes is not enough to do justice to this, so I've done a short video so you can have a visual understanding of the project.
Sorry, sound is not coming.
Okay, since there's no sound, this project catered to 500 children, so 250 boys and 250 girls, just to emphasize equality. And then this was a collaborative effort with a team of different professionals, engineers, astronomers, and then a key component, we had a team of counselors who conducted cognitive behavioral therapy assessment on the children, And then one key deliverable, which you're seeing now, is the solar-powered learning hub, which we set up in an abandoned shipping container. We turned it into like a mini room for inspiration for the children. So it has smart TV, internet capabilities, and it houses a hard drive full of astronomy education materials so as to inspire the kids. And then Astronomy World that has key information that can help the kids to dream, And this is the team, some of the team members that were there, and this are the children, some of the participants in the project, And it was funded by IAU and OED, and we say a big thank you to them. So I'll go next. Okay, as I mentioned before, it's a collaborative effort, and it's an ongoing project because in February we still have another session with the counselors to follow up. So the cognitive CBT assessments, cognitive behavioral therapy assessments, as I mentioned, we had counselors that were a key part of the project, and their assessments, on the kids were very vital because we need them to upgrade their mental health, And cognitive behavioral therapy is a psychosocial intervention
just to improve the mental health of the children that have passed through trauma of losing a parent and being displaced from their homes. So this test measures, it measures depression, stress, and anxiety. And then for depression, we ran reliability, and we saw that the data was reliable. And then these are the results. It's higher than the normal average for children. Also for anxiety, you rank higher for the average child, and for stress as well. In Nigeria today, this problem is endemic because there are over 2 million displaced children, and the figures are even rising. 2 million displaced people, mostly in the northern part of the country, and this creates a vacuum, a problem of inequality, the lack of proper education, and all the metrics that will make them a problem to the society. So it's an ongoing project, and I just want to say thank you. I think my time is done.
Sorry about the sound. Huh? Sorry about the sound.
Oh, no worries. Thank you.
Next up, we've got Margarita Malaro, who will tell us about a project to make STEM more inclusive.
This is right.
Yeah, let's forward in this one.
All right, let me start by briefly introducing myself. Not very.
Try again.
Right, this is me. Why did I say that? Because as a STEM graduate, I'm a fish in the STEM pond, right? And you can notice that I'm smiling in the pond. And that's because I'm a relatively big fish in the pond, right? I've succeeded against other fish in getting to master's, getting to PhD and postdoc program. And in a way, that's what all of you have done as well. We've succeeded against our competitors. The problem with this is that the pond in which we're competing is extremely small. It's not a representative sample of the talent in the population. And so actually, if there was a chance for them to compete fairly, you would notice that my job would probably be taken by someone who is better than me at what I do, just didn't have the opportunity to get to where I am. So the issue is, why are the fish not in the pond in the first place? So in South Africa in particular, there are very severe problems that prevent fish from getting in this pond. And in the case of Black women, the most serious ones are the ones listed here. And I think it might be a cynical perspective, but I do not think that science outreach, which is what I focus on, is what I devote myself to, is the most efficient way of tackling this problem. What we can do is try and get the fish that has somehow avoided all these problems and try and nurture them into STEM careers. And notice that here I'm being quite optimistic because I'm saying, oh, this big fish actually made it through, avoided all these problems. There's actually no reason why that should be the case. Fish that could make it through should be the smaller ones. And I think that's an important thing to bear in mind when we're talking about interventions such as positive discrimination later on down the line. So if we look at statistics of STEM representation of Black women, you can see that it's abysmal. So why is it? So as a privileged white European woman, let me tell you what challenges Black girls in underserved communities in South Africa face. And you can see that they start right away. So lack of quality early education, extremely high dropout rate between grades 9 and 10, which are mostly girls. And also a lack of engagement in science activities and a lack of opportunities to build confidence and interest in STEM subjects. So I'm privileged, So you can see that tackling inclusivity at a later stage is already too late. You got to get them young, you got to get them early to avoid all these issues. And this is recognized as a source of inequality. So I'm privileged to collaborate with a school in Khayelitsha. It's called Monotlava, and which develops schools targeting girls in these communities to provide them with a STEM-focused education. And through the OED, we're assisting them in providing young girls with astronomy activities at those stages. But you can see that even if you make it past this age, you still have girls that do not choose science subjects, they have no good career guidance, they don't have funding for university, they don't have an interest or an understanding of what a STEM subject is. I cannot stress how many good girls we're losing to accounting who could be good scientists. And something here, lack of role models.
Sorry.
So it's important to pick them up. And with Astronaut Clover, we have programs that tackle all of these stages. So just the main lesson you have to keep up the effort throughout the whole stage. This is just a few random ideas. If you want to maximize your efficiency, don't do it alone. Go to development and education initiatives that are local, that know what they're doing, and have networks existing. Astronomy is good bait. Kids like it, use it to involve them in programs that can actually tackle the problems they're facing. Astronomy can provide other resources, right? It doesn't matter if they're going to become astronomers eventually. Just use the funding that is available to say, just go to university, see what happens. And finally, we do have to remember that astronomy does allow us to provide an opportunity for girls to increase their STEM literacy and confidence. Thank you.
Thank you, Marguerite. Do we have Joshua here? So you please feel free to come up and chat to us about promoting radio astronomy in Ghana.
Thank you very much. Joshua from Ghana, and I'm here to talk about promoting radio astronomy in Ghana through school visits and astronomy clubs. We have a team. Okay, so this is the TRASAC outreach team. It's made up of graduates of Cohort 1, 2, 3, Ghana Basic Training Astronomy Program. And our objectives to increase awareness of the Ghana Radio Astronomy Observatory and the benefits it can bring to the local community, also to increase the understanding of astronomy and radio astronomy in particular to the students, and also to establish astronomy clubs, and also to increase interest in science, technology, engineering, mathematics subjects among the students, also to encourage more students to take up science at the senior high school levels. Okay, so our target audience is the junior high school students, and we currently have 7 schools that we are training. Okay, so we have our teaching methods where we have the trainers workshop, the initial PowerPoint presentation, formation of astronomy clubs, and we have the astronomy club sessions and educational visits. We have the club patrons workshop, and we also have the hands-on activities. So for the trainers workshop, we meet, strategize, and plan on how we go about the astronomy training program in the various schools. So we discuss about how we talk about the Earth, the Moon, the Sun, the galaxies, and hands-on activities that we can do with the students. Also, then we go to the schools, then we have our initial presentation. So here we can see some of the trainers educating them about the Ghana Radio Astronomy Observatory, about the basic astronomy stuff, and also astronomy in particular, and also what careers they can take in astronomy. And from here, we go for the club visits where we go to teach the students about astronomy, that's the sun, the moon, the earth, to inspire them to take in, to do science in the senior high schools. Okay, so when we go there for the club sessions, we always have a pre-assessment sheet and a post-assessment sheet to check whether we are able to impart something to the students. So you can see from the first session, we did fairly well. There was a good understanding of astronomy, and the second one too, there was also a good understanding of astronomy. We also had an educational visit at the Ghana Radio Astronomy Observatory, where we took the students to the Ghana Radio Astronomy Observatory. We took them around and also had some hands-on activities. Okay, we also have a club patrons workshop to educate and train the patrons of the astronomy clubs so that they can continue the astronomy program when we are not around. So this is some of the things the astronomy patrons did during the astronomy club sessions. And we also took part in the aerotics experiment where we have we measure the distance, the Earth radius using the sun's. And we also have some motivational speeches for the students to inspire them to take in astronomy courses. Also took part in the UN and IAU Women and Girls in Science activities. Conclusion, we saw a great enthusiasm of students and the teachers in the astronomy program, and the verbal feedback from the students and teachers indicates that this project can help inspire more students to take up STEM courses and consider careers with them. So we have some recommendations that we should have a more careful, consistent use of assessment sheets, and also we should have more training workshops, and we also need to collaborate and build a mobile planetarium. Okay, so acknowledgements and our social media platforms. Thank you.
Okay, up next from Burkina Faso, we've got Sikam, who will tell us about personnel development through astronomy.
Thank you. My name is Zaki Khan from Burkina Faso. I want to speak about astronomy in Burkina Faso. You know, Burkina Faso is a country in West Africa, and what we want to highlight here is the position of Burkina Faso, and the white dot is just the 1 meter side telescope in order to monitor the asteroid. And when you look at the position of Burkina Faso, we are not talking about the big telescope, we are just talking about small telescope. And Burkina Faso is a country where it is possible to do this kind of science. I will not come to talk about the story of astronomy in Burkina Faso. What I want to highlight here is just the process to implement the project of astronomy in Burkina Faso. The first thing was the need to set a pole of excellence in physics in Burkina Faso. The first thing was a political decision, in fact. And the second step was to make possible to have a training of qualified personnel for the research and also for the training. This is the important part of the project in Burkina Faso. And the third step is the establishment of adequate infrastructure in order to do the research and to do also the training. The next step also is research and professionalizing training in order to create a job. This is the shaman, the path of in order to implement our project in Burkina Faso. And all the projects around, you have a lot of activities around the project in Burkina Faso. Okay. Before coming back. The results. Okay, the results. The hope is to train people in astrophysics. The training program is set up, and you remember the first International Astronomical Union make the symposium at Ouagadougou in the same time we set up the AFAS Associated Society in Burkina Faso. One of the results we get about having high training people in Burkina Faso, we have 6 PhD through the program, and those people are working in the scientific level, participating to good meetings in a lot of topics.
The big one is to go forward.
Okay. Okay. What is going on? We have the master in astrophysics in Burkina Faso. This is the topic we are doing in Burkina Faso. You will see we have photonics in order to combine astrophysics, photonics, and instrumentation, because doing only astrophysics is not in a country like us, our country is not easier, but we are trying to add some other domain. And we are going in order to build a more bigger telescope. And we are also training students in the graduate level with the participation, collaboration with Paris, Marseille, Nice, and also we are looking for people to contribute. Thanks.
Thank you, Zachary. Aaron, please come forward. You're going to talk to us about astronomy as an example of interdisciplinary and cross-disciplinary study.
Do we have the remote control? Okay. I'm going to speak because this meeting, this workshop is devoted to the inter and multidisciplinary sciences, and many of us are astronomers. For other half of our attendees, it will be interesting to learn how deep astronomy has gone to other sciences, toward the other sciences, to create multi and interdisciplinary sciences. Even the IAU divisions, if we regard, we have now a lot of different divisions where you see facilities, technologies, data science. Here we have planetary systems and bioastronomy, etc. So many are related to other sciences, and astronomy is going closer and closer to other sciences. We have a lot of international organizations that support such approach, such studies. You see here we have both in informatics, even such organizations like UNESCO, related to astronomy, World Heritage, and others. Many really work on somehow approaching astronomy and other sciences. Just a few examples, because 4 minutes is very small time, so a few examples how astronomy works with others as astronomy and philosophy. You see the topics, many topics that are covered by this interdisciplinary science. And astronomy and physics, of course, is many more than 100 years, maybe 120 years that astrophysics is the main part of astronomy. Especially, we know that all physics is covered by cosmological time scale. And then astronomy and chemistry is very popular now, astrochemistry. Then we have astrobiology, one of the most important probably fields of astronomy, working also for exoplanets. We have astronomy and geology, sometimes we call it astrogeology or planetology. Sometimes important is comparative planetology, working with other planets and satellites, moons. With mathematics, we have a lot of joint topics, astrostatistics, etc., theoretical astrophysics, and informatics, the big data coming from the universe, are very important for all fields of science. With astronautics, of course, there are a lot of points of interest, especially celestial mechanics, one of the branches of astronomy, served as the basis of astronautics. And then with meteorology, space weather is how important, also as well as astroclimate, which is important for building observatories, and many other topics listed here. Then, of course, a very important part is history and archaeology, which is we call archaeoastronomy, and there are a lot of things that astronomers work on to improve our understanding of the history and our archaeology, as well as many topics related to culture are also regarded in astronomy as some subject, which is called astronomy and culture. So this means that the message and technology, of course. So my message is that astronomy is now not only one science, but something providing a lot of data for any science. So astronomy is, let us call not astronomy, but data coming from the universe, which of course astronomers obtain and analyze and provide to other sciences, which means that, for example, chemists will not build their own telescopes and will not train people to make observations, but So the best way is to collaborate with astronomy. So that's why astronomy becomes more and more important now for all sciences. Thank you very much.
Thanks, Arik, and that brings us to the end of the lightning talk. So now I'm going to hand it over to Neeraj, who will lead the panel discussion on science and society.
Thanks, Vanessa. Can I ask all the panelists to come forward and take this, please? So this panel is titled Science and Society, Knowledge, Skills and Engagement. And we have 5 panelists representing a vast diversity of skills and methodologies of engagement with society. Since each of them represent a large body of work, we're going to hear from each of them in terms of a 4-minute talk, like we've been doing for with the timer, following which we'll have discussions and questions addressed to all of them. So first, let me call on Lucia Marchetti from University of Cape Town and University of Western Cape here in Cape Town. She's going to talk of soapbox science project and opportunities.
You will time myself.
Yeah.
Okay. So, good morning, afternoon, everyone. So today I'm going to talk about this specific project that we have been developing here in South Africa, but it's actually an international collaboration. So what is soapbox science? So soapbox science basically works like this. You take 12 female scientists, one of those fish, as Margarita said, that have made through PhD or postdocs or even up to emeritus professor level. You bring them to a public square and you make them to talk to the people. So basically, you don't create, you don't bring the people to a science event, but you bring these female scientists to a place where science is nowhere to find. These scientists have all sorts of background and all sorts of science field in which they are, expert in. So we also provide the training to the scientists in public speaking. Some of them are not trained to do public speaking in a public square. And what we do, we also bring them and we make them wear this white coat. So now I am a chemist, basically, but you can clearly see the sign. And you are recognizable as a scientist from far away, standing on a box. So the idea is, how can I go on?
The big button.
I'm doing this. Oh, there you go. So I was pointing there. Okay. So as I said, this is an international project that started in 2011 in the UK and then spread all around the world. And last year we organized the first one in South Africa. This is the team involved. You see in red highlighted the people behind the scene helping me as a coordinator to produce the project, and all our volunteers and speakers. So a very diverse group of female scientists, activists in bringing science to the square and showing real role model that can inspire the new generation of girls into science, and possibly talk also to the parents of these little girls that might be amazed by the process. So we bring them to a public square. We brought them to the waterfront. If you have been in Cape Town, you know it's a very public and very vibrant space. And we made them engage with more than 500 people in 3 hours. Okay. So it has been very successful, and we ran a survey afterwards to actually, counting the people and see how and what they brought out of the event. And it's been very, very successful, and these are the partners that we had in the first edition. So the National Research Foundation, of course, the BSI, and any sponsor that patron that would like to join us in 2020, like the Academy of Science, and want to talk to me, please do it, because we're really looking forward to grow up. Another element, though, that I want to bring you to the attention is the network that is behind the soapbox science. So since 2011, we have more than 1,300 female scientists participating to these events all around the world. These are the countries that are involved in the 57 locations in 2020. They are all over the world. And the idea that I had behind the scene, which is not incorporated in the project right now, how we can use this network of female scientists that are definitely passionate about what they're doing to be mentors possibly to the next generation of young learners all around the world, connecting these together through possibly the alumni association of the Sobok Science speaker that we had. And can South Africa, maybe since I'm here right now, lead the way to create this mentorship international program that can help this type of network and bring most female scientists into the world? Thank you very much.
The code will be available outside, so you can take selfies.
Yes, we need all the support and the donation, of course.
Of a soapbox. Thank you, Lucia. The next speaker is M.S. Segla from Benin Republic University, the Borneo, Malawi. He's going to talk about mobile apps for illiterate populations.
Okay. I'm M.S. Segla from Benin Republic. I study Yoruba perception of ICT. ICT is information technology, communication technology. So how they use the mobile telephone nowadays. And two things before I go to the essential, because I have only 4 minutes. Two things is that first, there are barriers to use of ICT. Barriers are illiteracy. Literacy, how do you
No, it's this computer.
Okay, so barrier to use, go on. Let's go.
Okay, I'll advance it.
Okay. So illiteracy, you know that 80% middle class in Africa, and illiteracy is 80%, and middle class is that one that is using ICT. But the majority is still in the country, in the villages, and they are the majority of the society. So there is something very wrong and very injustice. And barrier to use is also the ICT is writing in foreign languages like English, French, and they don't write and they don't read these languages. The second degree of illiteracy is that in their own language, they don't write it and they don't read it. So this is very injustice, and they can't contribute to inclusive economy, inclusive growth. But however, in this condition, they try to use ICT, and so they create the imaginative technologies to use it. So they create, for instance, they imagine science to storage text, to storage images. They use this.
No, it's on this computer.
Okay.
It's here. Yeah.
So they use science. They use science to storage text, to storage the names, because you made somebody who can even don't know his own number. He can't save his own number. That's very, very problem. So all this, I met a woman that storage the number of her daughter who lives in Niamey, because Niamey is in Niger, Sahara, very lot of sound. So she used the sound to indicate that it is the number of her daughter. So there's very imaginative things that they are doing. Next. So this brings us to propose a mobile app to help them in society, to bring them to our level and to participate in the economy. And I want to show very briefly the scheme of the mobile apps. So the first stage is our ICT now. Now we can't build ICT. It is the long-term things. But the second stage is we can adapt. So we take the ICT now and we create a new language support in phone, or we create translation application in mother tongue. And next, I will show you next. Show you here, yes. So you have there now the ICT. So we can message coming from a people who is illiterate. We click on the message, and the message open this window, and in the window he can click again, and this voice translates the message into the mother tongue. So when it is translated in the mother tongue, the translation is written again. It's written in the mother tongue. So the people can learn about micro element of the language, so alphabet, and the macro element of the language, like tree in the mother tongue, tree will appear. So tree, it is the element of biology. So you can link this to the data bias for agronomy, so you can learn. It's a very, very good project. So we need money for that.
Thank you. The next speaker will be Michelle Vilbrand from Leiden University, Netherlands, on the Pale Blue Dot.
Thank you. So we've seen a lot of examples already of how astronomy can contribute to development. We've seen from the many links it has to different sciences. We've heard about the big data and the technologies that come from it that have a huge impact on societies worldwide. And I want to highlight the effect that inspiration has and how powerful this can be, and how astronomy can help us with this. This is something that we've been doing in Leiden for a long time, and I want to say that Catalina started with this a long time ago already, being a great help. And now we're continuing with that in this project called Pale Blue Dots. And this starts from all these images from astronomy that show our Earth from space, that show our tiny blue dots. And I don't think anyone can say it better than Carl Sagan already has. Look again at that dot. That's here, that's home. And he says that it underscores our responsibility to deal more kindly with one another, but also to preserve our Earth as more fragile than it might seem when you're down here. And this inspiration, this cosmic perspective of our Earth is extremely powerful. It can be used to show people that we are not so different from one another. We can be more tolerant to other cultures, and in this way stimulate social cohesion. And it shows us the fragility of our Earth. It shows us that we have limited resources. We are just one spot in this vastness of space, and we should cherish it. So these are sort of three objectives that we try to achieve with our project. It's about tolerance, it's about climate change, and of course it's also something about wonders of science. It's attracting children worldwide to science by using astronomy as a gate. So the project that we are running is an education project, formal education for young children 6 to 8 years old. And the reason why we chose this is because young children are still very open to the world. This is when you're going to have an impact on how they see each other, themselves, and the rest of the world. So this is the age group where we can have a lot of impact on their value systems. And of course, when you're doing an education project on a global scale, cultures are different everywhere. Education is different everywhere. And you have to work with local people to know how you can reach children locally and adapt it to local cultures. And the final slide that I have is about the fact that we also have part about researching this message. There have been a lot of projects using astronomy for the sense of global citizenship, seeing ourselves as citizens of the entire Earth and not just as our national countries. But this is also something that's very difficult to quantify. How big is this effect, and is it lasting? And this is something that is very important, however. Everyone here knows that sometimes you need to quantify, and you need to be able to know what the exact impact is of what you do for people to see that it's valuable what you do. So this is why we've decided to pick this up as a multidisciplinary research platform. And it's highlighted many times before that development is very multidisciplinary. Everyone needs to be on board to know what the effects are. So we take this opportunity to bring in people from different sciences in Europe as well, the same as we're doing here, to discuss together how can we see what the effect is of the inspiration of astronomy. Thank you.
Thanks, Michelle. The next speaker is Nadeem Uzair from Sarao, formerly SK South Africa, on innovative and transformative education for Africa.
Thank you very much, Neeraj. So we all know, and we've been hearing, this morning, that education is very important, and we want to change the world. And I will be talking about what we've done here, in Africa within a span of 10 years, how we changed things. So in order to do that, is it try? We know, and we heard it also this morning that education does bring and contribute to the GDP of a country, but in a long term. So we would need investment. All of us can be talking about, okay, we need money, okay, we want more money. At the same time, okay, what we also want, okay, you want growth. And this growth, okay, takes time. And the people, okay, who also invest in you, they want their return on investment very fast. So how do you do that? How do you build the human capacity for big projects like the SKA? And for us, what we believe is innovative way of doing things. Bringing innovation, bring people, okay, from management, and try to build new ways, okay, of teaching. Okay, what we do is basically remove everything that we don't like in workshops, in conferences, where you have a one-man standing and 30% of the people, okay, are on the laptop checking the emails, or they want to check, okay, what's next tonight, okay, for eating. Okay, so we remove every things, okay, that we don't like, and we come, okay, with vision, we get resources, we get the stakeholders also, the government, the people, we see what is it that, okay, they are looking for. The funders, okay, we say, okay, what is the niche, okay, that the funders, okay, want? And then, okay, we work towards building a model, okay, around these niches. And education, okay, is a great platform and great way, okay, of doing this. So what we want to do is build a critical mass of people. Okay, lots of you, okay, have been doing that. Very often people say like, oh, to get critical mass, you need a large number of people. I would say like, yeah, but not necessarily. Okay, you want to have a group of people, or maybe one person, okay, who is committed to new changes, initiatives, ideas, and the willingness to change and to learn new things. Some of us, okay, we age, okay, in the system we are, we don't want to change. Okay, we have to embrace it and also change the approach, okay, to your work. So that's what I said, okay, we are the JEDI. Okay, we brought the Joint Exchange Development Initiative, which many of you, okay, on the African continent have heard about it, introduced by Professor Bruce Bassett and taken outside South America in 2011. You take a group of postdoc, undergrad, master's students, and you throw them, okay, into a nice place, and you give them lots of projects, okay, to work on. Like astronomers, okay, working on recommended system for the million, for what song, okay, you think, okay, it's going to make a hit, okay, in the coming years. And you get people, okay, to interact, to work on eye retinopathy disease, okay, but using image processing techniques, okay, that you use in radio astronomy for block detections. Doing this, we have trained more than 300 people, students, learners. Most of them, okay, have been absorbed, okay, through other programs like the DARA Big Data, the DARA Africa, radio astronomy. We started in Mauritius in 2011. Okay, we got already 12 PhD students, okay, in the formation coming up. So the thing is that these initiatives is not run only by me, because we don't only teach them, okay, about like doing research, but also about giving back to society, giving what you have learned and sharing. So in doing so, I will tell you, okay, I'm not going to brag about it. I've been able in the past decade to raise 5 million rand through this initiative. Okay, I mean, money is not a problem. It's just, okay, getting the critical mass of people and people, okay, who you can work with, get the strengths, and you work together and go for the money. Okay, it's no longer time to change. You have to change, okay, if you want to survive. And it's up to you what door you want to take. Thank you.
Thanks, the last speaker is Ranpal Gill from Aura and the Ruben of the US.
I know I'm standing between you and some food. Yeah.
Okay.
The Rubin Observatory's mission is to build a well-understood system that provides a vast astronomical data set for unprecedented discovery of the deep and dynamic universe. And I'm going to tell you what we're doing to make that mission a reality. We are building an optical telescope, a ground-based optical telescope in Chile, under construction since 2015. It will be a 10-year survey that starts in 2022, and it's got a construction budget of $671 million US. It's made up of a whole system. Like I said, the mirror, a 3,200 megapixel camera, the biggest camera ever made for a ground-based observatory. A telescope that can move the optics around the sky such that it will survey the southern sky every 3 to 4 nights. A 10-floor building, a petascale computing facility, and a whole lot of people. Some of the facts: 10 million alerts every night of what has changed in the sky. A catalogue with 32 trillion observations. 40 billion objects will be observed over 10 years. We'll have about 5,003,200 megapixel images. And finally, a 15 petabyte catalogue. On the education and public outreach side, my colleagues are working very hard to build a system that will help the public with all of this data that we're going to get, while offering accessible, and that being a key word, accessible and engaging experiences so that everyone can be a part of the discovery process. On the formal education side, they have a whole suite of science teams that they are working on, and they are providing these formal investigations which are open for teachers to take and translate and use in their classrooms to teach their students about astronomy. And these are all of the subjects that they are building informal investigations on. On the citizen science side, partnering with Zooniverse. Also, again, these will be projects provided in various languages. We have a plethora of multimedia, a lot of it's built in-house, a lot of it on contracts. Already 16 short videos that are available to Planetarium in specific formats. Over 6,000 assets, like the photos you've been seeing that I've been clicking through too quickly. We've completed an initial 360 virtual tour of our site on YouTube. You can go online, look up, down, and behind you and see what we're actually building. And a promotional video that outlines everything that we are working towards. For the general public, there will be online applications available, but also on the phone, just making sure that we provide a way for people to access all that information that we're going to be producing. Like I said, the 10-year survey starting in 2022, and this is brought to you by the communications team. This presentation is brought to you by the communications team, and that's my team there. And these are the ways that you can keep in touch with us. Thank you.
Some of the panelists said they needed money, so you know whom to ask after this. So what we're going to do is, I'm just going to ask a few questions to each panelist, following which, if you want to ask questions to each other, we'll encourage that too, and then we just open it up for a few questions. That's all right. I need to see whether the class is so Lucia talked about SOapBox, the SOapBox project, which aims at providing role models, mentorship, breaking the alienation between scientists and general public, and so on. And you said that there are surveys taken after. So can you tell us a little bit about what were the responses in the survey? And secondly, motivated by the talk after you, how does one account for language differences and access to language and things like that in a public space?
Okay. Thank you. So first of all, about the survey. So yeah, this is a well-constructed project that coming from the UK, where they have a very specific standard of things that they want to evaluate to get to the government then and do the evaluation. So we have this survey provided already by the project, and in the survey we ask things like, where do you live? Where did you hear about the project? Is it the first time that you attend a scientific type of project? Would you attend something like this again? What is your age? Are you here with your family? Are you here alone? All these kind of elements and data that then, we can collect from one event to the other, and then see if there is a changing or a trend, and what type of and use this data possibly to improve along the line. In terms of bringing the scientists to the public space, breaks the alienation, of course, this separation between a scientist that is in the lab or in an observatory or at university with the general public, which is, they're just doing shopping, really, because that's what they were doing on a Saturday afternoon when we meet them. And that, I think, makes a real critical difference with this project between other events in which we have the open day at the university, for example. But in that case, the family has to bring the kid to the university for that purpose. While in this case, we're kind of interacting the Saturday afternoon or family, saying, well, my kid is actually enthusiastic about this biology that is talking about marines and fishes and everything, so I have to stop by and listen.
How do they listen? Well, the language is a problem. So when we did this in South Africa, we selected our speakers, and we actually asked an extra question to our speakers when we selected if they were, capable of speaking different languages, like native languages from around, Africa. And so some of them were able to speak native languages, Zulu and others, and so they could engage the public present in the different languages as well. So actually, not only speaking, at a level of science that is affordable to everyone and understandable, but also using a language that is very, very much in depth inside the family that is listening. So that was one of the things that we definitely did pay attention to.
Thanks. Talking of language, the next question is clearly to Segla. So you talked about signs and symbols, semiotics, and so on. And that reminded me, I'm old enough, but I still have millennial friends who use emojis like language, and so it reminded me a lot of how people communicate these days in emojis as well, including including some of you might have seen the EPO context. I think Katie Mack's tweet went viral last year where she used the emojis of sun, moon, and the earth on Twitter to explain what eclipses were, which very simple, but it went viral because it was really cute and so on, right? So my question was that I think this is a fantastic initiative, and people evolve their own ways of communicating. But then I would assume that people also evolve different dialects in terms of using different signs differently. And therefore, when you think of mobile app, you would be wanting to uniformize these sign dialects in some form. How does one do that with the consent of everybody, so everybody understands what the common new language in some sense of signs is? And secondly, what are the contexts for the normative literate communities where this kind of technique could be applied in science communication?
For the first question, I studied this with the Yoruba of the Benin Republic. Yoruba also are in Nigeria and in Togo. But in Benin Republic, we have several dialects of Yoruba. So, but the Yoruba is the same. It's the same word, the same roots. So even you take a dialect, you come to the Yoruba, the standard Yoruba. So it is not a novel apple for a dialect, it will be uniform. Yes. So the second question, I'm not sure I understand what you want in French. Yes, you can translate in French for me.
Avec les nouvelles technologies, les nouvelles découvertes scientifiques, comment est-ce que tu peux utiliser ton système pour passer l'information?
Tout à fait. We consider that modern technology is a chance for Africa to go ahead, to jump history. So with that, when I was studying this, I noticed that people are very enthusiastic and they use audio instead of writing. So they send each other audio messages and so on. So this is what inspired me to program, to code, and what they send them in French, for instance, to be translated in audio way. And at the same time, this audio way will be written for them in the mother tongue. So they will be training themselves in knowing how to write and to read their own language. And they can also learn the foreign language.
Thanks a lot, and thanks, Naveen, for translation. The next question is to Michelle, who talked about the pale blue dot. I want to be slightly provocative. So pale blue dot is something I identified heavily with, and the first 2 times I did it, I had tears in my eyes. So with that, let me be provocative and say, so if you think of things which people claim would unite us and bring together a common humanity, there are other examples in the past. Famously, I'm an atheist, but religion claims that as well, right? So how would this be different from those aspects, both in terms of content and methodology.
Right, and I think that's a very valid comment. We had this discussion the other day as well, that astronomy has a lot of negative attention in the media as well, with solar telescopes in Hawaii not being done right with local communities. And it might not unite everyone all the time. That is very true, and I think it does. But I do believe that it's one of those fields that speaks to the imagination of many. And everyone you do reach is someone that might refer to and that might have changed their way of thinking and their way of looking at the world. And in that way, astronomy might be one topic, and I encourage everyone to use different sciences, different topics, different methods to do the same thing. So even though there might be criticism, it's good to try in every field. Every field has a chance to unite people. And I don't think astronomy is necessarily different. Of course, we have a lot of these studies where we see that it is still one of the big topics for students of all ages to go into sciences. That is data that we have, and that is still vouching for us. But even those that do not choose astronomy, they still look at the sky and wonder about our roots. And I think this is still communal. This is one of the things that if you don't have any societies, if you look at everything that is the same everywhere around the world, people look up. And this is something that will always be the case. And that if you let go of the telescopes that we might have now in Hawaii, that might ruin a lot of things for a lot of people, we still have the same curiosity about our roots, about where we come from. And astronomy is a very powerful way of addressing those questions, among many other sciences.
Thanks. Nadine talked about JEDI workshops, joint
exchange.
Yes. So I had a couple of questions. One is, do you follow up with the students after this over the years, and if so, what has been the impact? Secondly, you talked of projects which are directly Science4Development, which you do with big data and machine learning in the workshop. But to take it forward after the workshop would need a supportive ecosystem involving the government, universities, corporate, etc. So do you help in facilitating that, or do you leave it to them to take it forward? In which case, what has been the success in that spot?
Yeah, so for the first question, okay, what we do normally, okay, we take the students, we bring them in an environment for 1 week. We all stay together and we learn and share the experience. You get to know the students. And very often what we have found is that we will work with a supervisor, a lecturer, okay, in the host country, and we'll start co-supervising, okay, the students. And what has worked also is that through that co-supervision, the students get very good grades, and then, okay, we try to bring them, for example, to South Africa, because the SK was a big driver, bring them to South Africa to do a master's, and then, okay, they continue with a PhD. On top of that, okay, what we also done is that through the JEDI, okay, we take a research topic, a scientific topic, and we work with the students and the researchers together, and we have got publication. We got more than dozens of publications. Not only have we done this JEDI workshop, okay, with students, we also took like 50 professors all around the world, put them in Mauritius. It's like, okay, fine. Now, give us challenging questions that you want to work. And that has now brought multidisciplinary and also intercontinental collaboration between researchers, where we've got great papers coming out. So we do follow them, and we also know now, because the DARA program, okay, came much after. Now, okay, we see that our students, okay, they are applying to the DARA. But because we spend time with them, we do research with them, we can now write this, a recommendation, okay, a reference, okay, for them, for their application. So it's a very good way for you to know the student, because in Africa, you get someone, okay, who is somewhere in Namibia, so like, can you be a referee for me? And there is a problem because they don't get those chances, but because you interacted with them, you know them, and now, okay, they move. So a vast majority have moved into the DARA program. Some of them, okay, started their own business. For example, okay, we started with the DARA Big Data Africa in 2017. It has grown, and like I got this student who was with us last, like August, November, started a cyber SWAT in Madagascar, a company, his own company, and we keep on interacting with them. So yeah, so your second question was about
larger ecosystem to take it forward.
Yeah. So now what happened also is that, okay, it's very similar. I use this analogy, okay, when you start like playing soccer, okay, on the roadside, and then, okay, at some stage, okay, you become very good player, and people's like, oh, cool, okay, I want this soccer player, okay, to be in my team, and then, okay, you become like very famous internationally, and like now, okay, what do you do next? Okay, that's we face that problem. Is that people, okay, say like, hey, your model, okay, has been working, you're getting lots of money. I think now, okay, we can't give you money, but like what we do, we have to adapt because we keep on learning and changing ourselves. So now what we do, we go and to companies like Amazon, IBM, and Google. So like, hey, we are running this program. You come on board, it's a win-win. We get the training, you get the bright student, you take them on board, or you take up the business. So in the end, okay, everybody wins. And I can say that, I mean, I got students, okay, all around, okay, like working like in data science and lots of other projects. So till today, I mean, this is a very successful model. And as I say, even the JEDI keep on changing from year to year because we learn, okay, what did not work, and we change. We never repeated, okay, the same format. We've done it in Mozambique, Madagascar, Namibia, Kenya, Mauritius, South Africa. And now, okay, people coming to us like, hey, do you want to run a JEDI? It's like, no, we don't have time. But the students, okay, are there now to take over. Thank you.
Thanks, Sadiq. And lastly, Ranpal, and I've been told food is ready, so we'll have questions for Ranpal, and then we'll have you. If you have questions for them, we'll have to ask them during lunchtime. So Ranpal, sorry.
Can we interact or
No, but you could also go late for lunch and keep talking to them if they are happy to stay. But that's between you and them. Okay. The organizers say the lunch is ready. Okay. So Ranpal, you talked of the Rubin Observatory and this really grand EPO and communication work you're planning for the next coming years, and then you started it from scratch with the project itself, which I think is fairly unique. The question is, what is that? How decentralized is going to be in the sense that if some schools or colleges in Rubin Observatory country like South Africa or in a non-Rubin Observatory country, South Africa, how easily can they plug in? And secondly, what kind of connections do you have with other EPO projects of other astronomy mega projects? Because STSS has one, Chandra has one, and so on. NASA has one, of course. So do you all coordinate at some level, or is that something that is yet to come?
You asked two questions. The first one was,
how do people in Rubin Observatory countries and non-Rubin Observatory countries plug in?
so the development obviously is that the construction is happening in Chile, and we are a US funded and run project. So in those are the two countries where we're mainly focusing on the formal education side of things. So everything conforms to the curriculum in the US and in Chile. But those formal education, those themes and those formal investigations that I showed you can be translated into any country, into any language for any country, for any formal curriculum, I believe. That material will be freely available. For citizen science, that's through Zooniverse, and that will depend on principal investigators having data rights, and then opening up those projects, and those projects will be available to anyone. It's actually the Zooniverse platform that enables those projects to be available in whichever language.
The second question was, is there some coordination between EPO programs of various astronomy mega projects?
So I'm not too sure. It's possible that that's just at an informal level right now and still to be developed.
So we are run out of time, but let's thank all the speakers. Again, for the first time. And please catch them outside at lunchtime. They presented details of fascinating projects, all very different, all very diverse, and all having lessons for all of us in our work. So thanks everybody, and we'll be for long.
Thanks everyone, and let's give a round of applause also to the lightning folks in the session.
Okay, some quick announcements. All the speakers in the next session, please come to me and give me your presentations. People have been asking about dinner. The dinner will be here at the observatory. The plan after the end of the program at 5 o'clock is that Christian, one of our astronomers here, is going to give you a tour of the observatory if you want one, and then dinner will be straight after that. See, the thing about smartphones is that they need to identify you. If you haven't signed the register already, please sign the register in the overflow room during lunch. The unconferenced topics are there, it's filling up, but please put a tick near the ones that you like so that we can see which are the more popular ones. You're going to go out for lunch now. If you haven't asked for vegetarian food, please don't eat the vegetarian food. There's going to be a vegetarian station. There's 2 food stations, one in there and one just out here. And then there's a vegetarian station against the far wall. If you haven't asked for vegetarians, leave it for the vegetarians. Yeah. And then we're going to do a group photo now as we go out. So if you just go out onto the steps here, we'll just take a quick group photo and then you can help yourself to lunch. Thanks very much.
Take a picture, please take a picture. Support. We need all the
Yeah, if you can please just move on to the steps, we'll take a quick group photo and then people are.
Basically, all the sort of sciences are
Taking presentations. Yeah, I'll take it. Guys, can you come outside? Everyone's feeling very hot outside. Yeah.
I'm fine, and you? Sunshine, though, so.
Yes, just on the front table.
You want to test the mic?
Thank you very much. Thank you.
Right. Yeah. Okay, everyone's here. Hold on. wide. Vegetarian. No, oh, what happened? Let me. We're going to pause the streaming now. We'll continue it after lunch.
We do that. Say again? Yeah. Excellent.
I should try. I'll just say. Okay. Can I try today?
Yeah, that one. What's the date?
Yeah, that's it.
Yeah. Okay.
Is there a sound file on this?
Yeah.
Scroll to the next slide.
Yeah.
I can't hear you. I might want to be here.
Okay.
So you should. So I'll try and once we're done with it. Yeah, so I'll replace that. I'll be right there. Yeah, just let me know. There's a problem with this drive. Let me just check. It's a PDF, right? Yes. Oh, I've got yours already.
Yeah, I sent you my. I sent you my thing. Can you open it to see?
Yeah, just come and check, Stanley. So it'll show up like this. Okay, Stanley said. So you also need to.
No, I just wanted to confirm that I sent you mine in the morning. Okay, so that's good.
Felix, yeah, let me just make sure that it's the latest one. You want to have a look? Which one is it? Role of IT?
No, health and happiness. It has updated, yes, it's the latest. Has
Okay.
updated. Thank you.
Perfect, cool. How are you, Claudio?
Fine.
Hey, yeah, right, man. Sorry, not,
Okay. Ready?
Can I have my...
Oh, yes, please, sorry. I'm just going to stop the live stream.
Okay, ready?
How can you pause this?
Okay, and one more.
Okay, thank you.
Cool.
Kevin, I sent you by email. Did you find mine?
Well, what is the name of
Bridging gaps, something.
Yeah, check this one.
Yes, that's it.
Yeah. Okay, cool.
Yeah, no, let's go. Kevin, I do believe you deserve a proper portrait. That's awesome. The ones I have of you yesterday, were on a white background.
Yeah, I know.
It was just like, you're not.
It's fine. I'm used to that.
Well, I've been. Yeah, it's fine. Fine?